In this course, I'm going to show you how to create a complete mining roguelite game from scratch. You'll learn how to build a fully animated player character with smooth movement and mining mechanics. We'll dive into random level generation, create an inventory system, and build a shop where players can upgrade their gear in between runs. By the end, you'll have a finished game and understand how all of these systems connect together, which you can then apply to any game that you want to make. This free tutorial covers the core mechanics, player movement, mining, and basic rocks to break. The full course on Udemy adds the inventory system, shop upgrades, multiple level layouts, ore variety, and oxygen survival mechanics. The link for that course is in the description and in the pinned comment below. We're going to begin with a blank Godot project. And the first thing I'm going to create is the player character. So for that, we head over into the scene tree on the left-hand side, and we select one of these options. By default, Godot tries to help us with a few of the standard options like a 2D scene, 3D scene, or a user interface. But what we're using for the player is going to be a little bit more complex, so we'll head into Other Node, and then we'll search for Character Body 2D, which is this node down here. And this is typically what we would use for a 2D character. I can then rename that node to be player, and I can start building it out. For the player, I intend to use this cute fantasy RPG asset pack. There are two different versions of it. There's the standard free pack as well as a premium pack which has more animations and more sprites. But for this course, we'll just stick with the standard pack so that everybody can get all of the same images. This asset pack includes a player character. And not only that, it has multiple animation types and 4 different directions, so it's perfect for our top-down 2D game. But what is also quite handy is that it actually has a few different actions. I don't need most of them, but the mining one is what I'm going to use in this game. Once I've downloaded that asset pack and go into the player folder inside of it, there's going to be 2 different sprite sheets, player and player actions. Player has got multiple animation styles, so there's idle, run, attack, which we're not going to use, and the dying animation in different directions. And then player action has all the different action types, so we're just interested in these ones at the top, which is the mining animation. The first thing we need to do is get those images into our project. So down here in the bottom left, we have our file system. This is the project folder, and right now it just contains the default icon that comes with all of the Godot projects. So we're going to build this out by right-clicking on the root folder, select Create New, and add a new folder. We'll name this folder Assets, and then since we can have multiple types of assets like images and sound effects and so on, we'll create another child folder inside of that one, which we will call Images. Then open that one out, and on side images, we create another child folder, which we'll call player. Now I can open up the player folder and drag over those 2 files, the player and player action sprite sheets, into this folder. So now we've had them loaded inside of Godot, and we can access these 2 sprite sheets. To attach them onto our player, we'll right click on the player node and add a child node to it. So if I search up Sprite 2D, I'm going to get a couple of different options. There's just Sprite 2D on its own, and then Animated Sprite 2D. For static images, Sprite 2D is fine, but because our player is going to be animated, we want to use Animated Sprite 2D. Then we'll head over to the right, click in here and create new sprite frames. Click again to select it, and that will bring up this menu at the bottom. This is where we can actually configure the different animations. The player has quite a few animations and they're in different directions, so we'll have to create all of them eventually. But let's just begin with idle underscore down. So this is going to be the idle animation with the player facing down. To assign images into it, we can select this button here, which adds frames from a sprite sheet. We can then navigate to the file that we've just loaded, which is our player.png. And Godot is going to automatically try and split the sprite sheet into different tiles. So you can see on the top right, it says horizontal 4 and vertical 4. So it's basically just split this into a 4x4 grid. But in reality, we have far more images than that. Horizontally, we have 1, 2, 3, 4, 5, 6. So we'll change that number. And vertically we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So vertical goes to 10. And with that done, we now have each of the individual images or each individual frames inside of their own square. So now it's much easier for us to select specific tiles or specific frames to use in the animation. Because this is the idle down animation, it is the top row. So I just click on the first one and drag across to select all of them, then add the 6 frames, and now I have my animated images. And we should be able to see this. If we zoom right in on our image, we can see the sprite coming up here for the player. But you notice that the player is very blurry. So what we can do to fix that is on the right hand side under the canvas item, go into texture and change filter from inherit to nearest. So that immediately sharpens up the image and now we can actually see it as pixel art. However, it will be a bit of a pain to have to manually do this for every single image that we're going to load in. So let's undo this, it'll go blurry again, and instead we go and apply this change project wide. So we go into project settings in the top left, and then I'm going to search for the same setting, which was filter. We go into rendering and textures and change that default texture filter from linear to nearest. Now it's going to apply it again, but it will apply to every sprite that we load in. Now we can test out the animation if we click play down here, and you can see the player's running through the idle animation. Now let's see how it actually looks inside of our game. At the moment, the scene is not saved. So it says at the top, unsaved, but we can save that by either going up here and selecting save scene or save scene as, or I just press Ctrl S, and that brings up the save menu. We're going to store our scenes in a separate folder again. So let's create a new folder, which is going to be called scenes. And inside of here is where I'm going to save the player scene. Now I can test out just this scene alone. Over here in the top right, there's a few different buttons. This one here says run current scene. The shortcut is F6, so that's what I'm going to use instead. And that brings up my player scene. Initially, it looks like there's nothing here and it's not worked, but you can just about make out in the top left a few pixels. So that is our player. If we go back into the editor, we can actually see why that's happening. So when I zoom out, you'll see this bluish purple square or rectangle out here. This outline is the outline of our game window. So that is how big the game screen is going to be, and that is how small our sprite is. Not only that, the sprite is also in the top left corner, so all we're seeing is 1/4 of it. First of all, let's fix the scaling problem. Now what we could do is take that sprite or take the entire node and just increase the scale, make it bigger. But we're then going to have to do that for all of our images. So instead, we're going to make our game window match the resolution of the sprite. So we head back into the project settings again, and this time I'm going to get rid of the filter and go down to the display and select window. This here gives me the default viewport width and height. So this is the current resolution of my game, but the sprites are far smaller than that. So I'm going to change this down to 320 by 180. So let's run this again. And actually, even before I run it, you can see it's updated. And this bluish purple rectangle is now a lot smaller. And relative to this, the player actually looks more reasonable. So let's press F6 again to run this game. Well, the problem now is kind of different because the game window is absolutely tiny. So the player relative to it is okay, but the window is far too small for the monitor size. We need to scale everything back up again. So we head back into the project settings and the window, and down here, window width override and window height override allow me to keep my resolution small, but then scale the entire game up instead. So here, I'm going to go with a more standard resolution of 1280 by 720. And just to make sure that all of the scaling works correctly, under stretch mode, I'm going to select canvas items. So now if we press F6 to run the game again, the game window is showing up at the correct resolution, 1280 by 720. And the player is now a lot more visible. Sure, we can still only see one corner, but it's now the correct size for my game window. The player is almost created, but you'll notice up here we've got this warning light. And if I hover over it, it'll say that this node has no shape, so it can't collide or interact with other objects. At the moment, it's just an image. So if we had our level with all the rocks and everything else on it, this image is going to go through everything. It's not going to collide with any of the other objects. To fix that, I need to make sure that it has a collision shape, so that Godot knows which parts of it need to collide with other objects. So we create another child node, which is going to be collision shape 2D. Then we head over here and select rectangle shape 2D, which will create a rectangle that pretty much bounds the player and a little bit more than. But I actually don't need such a massive collision shape, so I'm going to resize this. I'm going to reduce it down to just where his feet are, so above the shadow, and to about the width of his body. And I'm not going to include his head, so it's just going to be the player's torso that's going to be inside of the collision shape. And that is our player basically created. Sure, we don't have a lot of the functionality, but the structure of it now exists. The next thing I want to move on to is player controls, so that we can actually move the player around. For that, we're going to have to get into some code. So we select our player node here and click Add New Script. This will create a new script for us, and by default, it wants to put it into the same scenes folder, but I want to keep them separate. So we're going to go into the folder structure, go up to the root, and create a new folder here, which is going to be called scripts. Now I can save my player.gd file inside of the scripts folder instead. This immediately brings up a pre-populated script for the player. This is because the character body that we've used as our primary node here already has some functionality. So at the start, Godot extends character body 2D, meaning that anything that comes by default with this node type is included in this functionality. And typically, this is associated with characters in top-down games, but also in platformers, which is why it gives us some variables like jump velocity, or even the functionality for being able to jump, which in our game isn't going to be relevant. So we can start making some changes immediately here. We can get rid of the jump velocity and just keep the player's speed. And I'm going to change that to 100 instead of 300. Then inside of the physics process function, which essentially handles everything that happens with the player throughout the game, we can get rid of quite a lot of this code as well. We don't need to add gravity. The player is always going to be on the ground, and we don't need to handle jumping. So this section of code can come out as well. What we're then left with is controls to move the player left and right. So this first line of code here takes a direction based on inputs, left and right, which are the arrow keys on the keyboard. Then, as long as a direction exists, meaning that there is being a left or right arrow key pressed, then the player is giving an X velocity. Finally, we call the move and slide function, which is built into Godot, which is handy. We don't have to define any of that ourselves. Godot will handle the movement and the collisions all inside of this one function call. And we can actually run this code as it is. So if I press F6, it's going to run this current scene. It loads the player up in the top left, but if I press the right and left arrow keys, I can actually move him around. And that's because of this code that's already existing. The limitation though is that we can only go left and right, but in our game we need to go up and down as well. So what we need to do is define some inputs that the player can now take. You'll notice there's some comments here that have been added by default. So this first one explains that we're getting input direction and handling movement and deceleration. But the second one says, as good practice, you should replace UI actions, which are these UI underscore, with custom gameplay actions. And that's what we're going to do. So we're going to get rid of that comment. Then we head into project and project settings and switch over to the input map tab. So here there's no input maps at the moment, but we're going to create new actions. So under add new action, let's just create one called up. So this is going to be whenever the player moves up. To actually assign a key onto that, we select this plus icon. So if you want to use the left, right, up and down, you could just press the up arrow key and that's going to bind it. But I prefer using WASD for controls. So I'm actually going to press W and use that as my input. So now it's assigned the W key into the up action. I just then repeat the same thing a few times. So I'll assign one for down, left, and right. Down is going to be done with the S key. Left is going to be A, and right is going to be D. Now that we've got these created, we can assign them into our player script. So right now, the direction variable is taken using the getAxis function and two inputs, left and right. But we have 4 inputs now. So we're going to change this getAxis to get_vector, so that we can move in both the X and the Y directions, or the X and Y axis. In here, we actually just put in order our different actions. So they go from, well, I'll just type them out. It's left, right, up, and down. So what I put in here are the names of the different actions that we just defined in our input maps, but they do need to go in a specific order. So I could have named this anything, but it has to be the one that moves the character to the left. We can now tidy up the code below. It doesn't really work for 4-directional movement as well as it did for 2-directional movement. So let's get rid of pretty much all of it, but just keep the if direction part. And what we'll say here is, as long as the direction is not equal to vector2.0, which essentially means that there is some direction, so we've pressed something on the keys, then we want to take the player's velocity and we want to calculate this as our direction multiplied by the speed, which was already defined previously. So whichever direction the player is moving in and the speed that it's moving at is going to give us our velocity. So let's just add a little line here. So that gives us the if statement, but then we say else, meaning that there is no direction. Well, in that case, the player needs to stop. So the velocity becomes vector2.0. And I think that should work. So let's press F6 to run this. And I'm going to test out. Yeah, so now I can move the player around using WASD. So I can move in all 4 different directions, and I can even move diagonally. So that's all working pretty well. But over time, this script is going to start getting quite messy. There'll be more and more things that we're going to add. So it's better to start organizing everything now. This physics process function is kind of the brain of the player script. It's going to call basically everything as long as the game is running. So I don't want to fill it up with too much code. Instead, I want to move these specific sections of code into their own functions. So down the bottom, let's create another function, which we'll call process_movement. It doesn't take any arguments and it doesn't return anything. So we'll just add void at the end. And what I'll do is just take this code, cut it from here, and put it inside of this function. And now inside of the physics process, I still need that code to run. So I'm going to call the function instead. So I'll say process_movement. And I still keep move and slide where it was before. So if I test this again, the functionality is exactly the same as before, but the code is that little bit neater. We've now got a separate function for handling the movement. Also notice that a little error, or rather just a warning, has come up at the bottom. So if we click on this debugger, it will give us one error, which says that the parameter delta is never used in the function physics process, which is true. There is a variable here, but we don't actually use it inside of anything. So just to get rid of this warning, we can add an underscore at the beginning of it. And if I rerun this with F6, that clears the error. It's not a game-breaking error at all, it was just a warning, but I prefer to clear those and just keep the debugger completely empty. So now that we've got player movement figured out, we can move on to adding in different animations. Currently, our player is pretty much static. We're able to move him around on the screen, but you'll notice that it's just a still image. None of the animations that we've added, or none of the frames in the animation, are playing, but in addition to that, we don't actually have any other animation types added yet. Let's head back into the animated sprite 2D and bring up this animations editor. We currently have idle down, but it's not playing. We could fix that by just clicking this button here, which means it will autoplay on load. So if I press F6 now, it will actually just play that animation instead. But that doesn't really fix our problem. So I'll go back in there and I'm just going to turn that off. And instead, we're going to control our animations in our code. But before we can do that, we need to add the rest of them. So far, I've got idle down, but let's create another one, which is going to be idle underscore right. And at the same time, another one, which is idle underscore left. So that will take care of the 3 idle directions. No, that's not right. I need down, left, I need down, up, and right. So even though there are 4 directions, we only actually need to configure 3 of them. Down and up will use different images. Right will use a specific image, and then left will come onto. There's a little trick we can use to avoid having to create separate animations and separate sprites for the left direction. You might already be able to guess what that's going to be, but we'll explain that when we get there. For now, let's configure the rest of these images. So we've got idle down, let's go idle up. So we click this button here to add frames from a sprite sheet, select the same player sprite sheet, and it's actually remembered my settings from before, so 6 by 10 types of frames. So that makes it a little bit easier for me. The one I'm doing is idle up, so that is the 3rd row. So just select all of those. And then we can do idle right in the same way, load that in, and it's the 2nd row. So that's actually it. I have my 3 idle animations. Now I can do the same for the run animation while I'm here. And the process is exactly the same. So as a little challenge for yourself, why don't you pause the video here and try and configure your own run animations. The naming will be run down, run right, and run up. So basically the same as this, but replace idle with run. And then choose the appropriate frames from the sprite sheet. And in the meantime, I will do the same thing here if you want to follow along. So we'll say run underscore down. Then I'll just add 2 at once. Second one is going to be run underscore up. And then run underscore right. They're automatically sorted alphabetically anyway, so it doesn't matter which one I make first. So run down, we head into here, select the player sprite, and that is this row here. So that's the run down animation. Run right, I'll do the same thing. And then we just need run up, which is this one here. And I can test all of these out, or at least preview them. So I can click play and it's going to run the different animations. So the run animation or the idle. And one thing I noticed when I was making this game is the idle animation speed is okay, but I kind of felt like the run animation is just a little bit too slow, by default anyway. So the default animation speed is 5 frames per second. You can change that to a different number. So if I said 10, then it looks a little bit too fast. So it's like the player is sprinting. So when I was making this game, I think 7 is right about there. So it gives a pretty good balance between too slow and too fast. So I'm actually going to set all of the run animations to use 7 frames per second. So they are just a little bit faster. But now we actually need to get all of these into our code, or at least we need to get our code to select the correct one to play. So we head back into our script and then let's get rid of this here. And this animation stuff is also going to happen inside of physics process. But to keep things clean just from the outset, let's start with a new function. This function will be called play underscore animation. And it's going to take one argument, which is going to be the prefix, which we'll say has to be a string. So after that, we don't pass anything back, we don't return anything, so we just add void at the end. And what this function will then be able to do is use this prefix, which we're going to pass as either run or idle, and it's going to play the appropriate animation. So it means we can use one function to actually choose different types of animations. So what we want to do here is get our animated sprite, this node here, and set the animation to something specific, and then play it. But how do we access any of these nodes from our script? Well, one way to do that is just to click and drag it over. When you do that, it creates a reference into that particular node, which we can then interact with. But because in this case, I'm going to be activating and speaking to the sprite multiple times, I need to create a reference for it instead. So I do the same thing, I click and drag it over, but before I release the mouse, I'm going to hold Control, and let me just put it underneath as constant. And when I let go this time, it creates an onReady variable instead. So this creates a variable called animated sprite 2D, which I can rename to anything I want, but this kind of makes sense as it is. And it by default or by itself links it into this node. So now in my code, if I want to tell this node to do something, I just speak to this variable. So we'll take that variable, we'll put it inside of our play animation function, and then at the end say .play. And what we want to put inside of these brackets is the name of the animation. And you can see it's actually it's given us some options based on the animations we've just created. So there's the 3 idles and the 3 runs. So let's say I select run up. Then if I call this function play animation inside of my physics process function up here, then I would need to pass one argument, which is the prefix. So for now, it actually doesn't matter. We're not using it, but just so that the function runs and gets rid of this error, let's just put run in the brackets. So if I press F6, I'm now getting the run up animation. So it doesn't matter what I'm doing, it's always the same animation. But what we want to do is be able to differentiate between the different animation types. So that means that when we have movement, we need to be playing the run animation, and when the player is stationary, he needs to play the idle animation. And we can do this based on the player's velocity. So instead of calling play animation directly here, let's add some code either side. We'll take the player's velocity. So we'll say if the velocity is not equal to vector2.0, this means that the player is on the move. They have at least some kind of velocity. And I've made a typo here, vector2. So if that is the case, then we're going to play the run animation. If that is not the case, so we'll just put an else, then we're going to play the idle animation because the player is not moving. So now inside of our play animation function, we can use that prefix. So rather than just saying run, we can actually change that to whatever we need, whether it's idle or run. So we get rid of that and say at the start, prefix plus up. So we'll work out the directions shortly, but for now, I just want to change between idle and run animations. And if we press F6, that should now work. So as long as I'm moving, the player is running. As soon as I stop, it switches back to idle. It's still going in the up direction, but at least the animation types are now changing correctly. I did say earlier though that I like to keep the physics process function clean, and any functionality should go inside of its own function whenever it's reasonable. So what we're actually going to do is take this code, cut it out of here, clean this up, and then after process movement but before play animation, we will create another function called process animation. This takes no arguments and doesn't return anything, but inside is where I'm going to paste that code. Now I need to make sure that this function is actually running, so we call it inside of physics process. So basically this is where the code was previously, but now it's calling a function, and this function is what contains that code. We've broken up the animations into 2 stages. We first decide whether it's the player is running or idle, and eventually we'll have other animations as well, like mining and the death animation. So that logic will be inside process, but then actually playing it is going to be inside of a different function. So if I press F6, everything should be as before. So I'm still able to control the player and switch between idle and run. So now let's fix this problem of only having one animation direction. We want to know which way the player is facing. And that is defined inside of this process movement function. There's a direction variable. We can't actually use this directly because this variable is local. Is defined inside of the function, meaning that if we try to call it somewhere else, like in this function here, it won't work because, because this is not declared in the current scope. So the only place that this exists is inside of the process movement function. I could declare it outside globally, but I actually need to be able to keep track of that direction anyway. So what I'm going to do is at the very top here, after my constants, I will create a variable. This will be called last direction, and it's going to be a type of vector2. And by default, I'll have the player facing right. So we'll say vector2 dot right. Now inside of the process movement function, after I've gotten input and I've got a new direction, we have this if statement. So this checks if the direction variable actually exists, i.e. we've given some kind of input and it's not 0, and we calculate the velocity. So after that, let's store that direction inside of the last direction variable. So the reason we're doing that is because as soon as I let go of any of these buttons, my direction is going to reset back to nothing, vector 0. But I need to store the direction of the player so that even if he was moving to the right and then he stopped moving, he should still face to the right. So last direction basically remembers where he was moving before he stopped moving. And now this variable is global, so we can access it and pass it around between our different functions. So inside of process animation, where I tell my play animation function which type to play, whether it's run or idle, let's also add in a direction, which we can use the last direction variable. So this becomes my second argument, which I then need to receive inside of this function. So we'll say dir for direction is a vector2. Now that I have this, I can actually determine the direction the player is moving in and choose the appropriate animation. So first let's do left and right. And I think we only actually have, well, I know that we only have one direction, but I can't remember if it's left or right. It's right. So the right animation is the only one we have. We don't have left. So we'll fix that in a second. But let's begin with the right animation. And the way that's going to play is if the direction or the X component of this direction is not 0. So as long as the player is moving along the X-axis in any direction, it means he's moving either left or right. So let's say if dir.x is not equal to 0, then animated, well, I can just take the code from below and indent it. So we play the prefix and the animation that we've got is right. Then let's do the same thing. So we say elif dir.y this time. If that's less than 0, then that means that the player is moving up the screen. So the animation direction is going to be up. And lastly, let's just make a bit more space here. Lastly, we say, copy this down, and we'll say elif direction y is greater than 0, then we play the down animation because the player is moving down the screen. So let's just test this out, see if that works, and it does. So now I can move around left and right, up and down. The only problem is if I go left, the player still plays the right animation because that's the only directional animation that we've got, left or right. So what we need to do is basically just flip the image. That's why there is no left animation. It's because it's just a mirror image of the right animation. We should actually be able to see this in the editor. So if I go back to 2D view and select my animated sprite 2D, then on the right hand side here, I think it's offset. Yeah, under offset, there's flip H and flip V. So we can flip it horizontally or vertically. So if I tick this box, the player is now running to the left using the same animation frames. So it just saves having to duplicate the directional animation. We can just use the same thing, but reverse it or flip it. Now to access that with code, we can go back into our script and down here where we're working out whether or not it's moving left or right, we can add another check, which is going to be our animated sprite 2D variable dot flip underscore H, which is this property here. This is either true or false. We're either flipping it or we're not. And it should only be true if the player is moving left, which is when the direction X is less than 0. So as long as the player is moving left and this is true, then the sprite's going to be flipped. But if you move to the right, then this is false and the sprite is not flipped. So let's try that out. Move to the right, it's okay. Move to the left and it flips around. And because we're using that last direction variable, whichever direction the player was running in, as soon as I let go of any inputs, it just stays facing that direction but in the idle animation. We will come back and add more animation types to this later, but for now, this is all we need. The player is now working well, we can move around and we can switch between directions and animation types. So now that we've got the player working, let's move on to something else, which is going to be the rocks that the player is going to mine. For that, we're going to create a new scene, and we'll select other nodes again. And for this, we'll use a static body 2D node. A static body 2D is essentially a collision node. So it's something that we can assign an image to, we can assign a collision shape to, but it doesn't move around, which is why it's a static body. And this node is ideal for something like a rock, which is just a fixed object that has an image and a collision shape, but it doesn't really have any physics in terms of movement. So now that we've created it, let's rename that to rock, and then we will need to assign an image to it. And for this, we're going to use another asset pack. So this one is called Hana Karaka, I think I'm pronouncing it correctly. And this is a dungeon and mining pack. This asset pack has really nice tiles that we're going to use for the levels themselves, so for the different levels of the mines, but it also has a lot of different types of rocks and ores that we can use. So once I unpack that asset pack, I've got a gems folder, well, I've got the ores and gems folder first, and inside there I've got the two different types. So inside of ores, we've got stone. And that's the one we're going to use initially, but there are quite a few other ones, and ideally we want some variety in the game. So we will come back to these, but for now let's just keep it simple and start off with the stone images. We'll need somewhere to store them. So we've got our images folder here, which has the player as a child folder. So let's create another one inside of images, and we'll call this one ores. And I can now drag over not just the stone, but I'll actually just drag all of the ores into this folder. So now I have in here, I've got the stone image, but I've also got silver, iron, gold, and coal. We don't have to use them all, but it's nice to have the variety. And actually, while we're here, let's just create another folder, which is going to be called gems. And the gems are from that same asset pack. So they're in the other folder called gems. There's amethyst and diamond. So let's just drag those over as well and get that all set up at the moment. So we've got all of our images. Now we can start assigning them, or at least assigning the stone onto this rock. Remember, for the player, we had the option of using Sprite 2D or Animated Sprite 2D. Well, the player has animation, so this made sense, but the rock doesn't have animations here. So we can just use a regular Sprite 2D. However, the image that we've got, so if we go into ores and stone, the image is a sprite sheet. So if I just drag this over, I end up with all of the different images or all the different potentials for a rock. I actually want to just pick one of these, which is going to be this bottom middle one. So what I can do is clear the texture and instead use a drop down and select an atlas texture. Then click it again to expand it and drag the stone over into the atlas at the bottom. So make sure you don't drag it into the top, that will just override it and replace it with another texture. So drag it into this bottom section where it says Atlas. Now that we have the Atlas, we can go into Edit Region, zoom in a little bit, and actually just select whatever it is that we want, which in my case is this rock here. However, it's very difficult to select it precisely, so we can choose different snap modes. I can try Grid Snap, which is actually pretty good. I mean, these images are 16 by 16, but 8 by 8 works well. I just need to capture 2 by 2 square. So this gets me an exact outline of this stone image. So that's looking a lot better. That's the stone configured. Then we can create a collision shape. So we add a child node, which is going to be collision shape 2D. And let's create a new shape. For the player, we use the rectangle, but for this, we can get away with a circle actually. So we just reduce the size a little bit. And I think that's close enough to what we need. It doesn't have to be super precise. So even though it doesn't match the pixels exactly, it's not really that important. As long as it gives close enough coverage for something like this, it's acceptable. It is possible to do a much more detailed collision shape, but the more detailed it is, the more complex the collision calculations become. So with something like this, an approximation is more than good enough. Now we can save this scene, go into our scenes folder and save it as rock scene. But how do we actually bring them together? So right now we have a rock on its own here, and I can press F6 to run this scene. We can see the rock in the top left, and I've got the player as well. But how do we put them together? Well, for that we need to create another scene, and that scene is where we're going to add both of these. So let's create a new scene here, and we can actually just select the default 2D scene, which will give us a node 2D. This is the most basic form of a 2D node in Godot. It has little functionality, but it can act as basically a container, a way of organizing different 2D nodes inside of it. So let's rename this to be our level. Now we can save this one as well, and we can add the player and the rock into this level. To do that, we can either click this little instantiate button here, or right click and choose instantiate child scene. It's the same thing. Then we can select our player. So now you can see the player is a child of the level, and we can move the player around anywhere here. Even though I've put him roughly in the middle of the screen, when I go back into the player scene, it's still in the top left. So the position here is relative to the level, this coordinate here. So we've got the player. Now let's also add in our rock. And we can move that as well. So let's save this, press F6. And now we've got the player and we've got a little rock. And also we have collision. So the player is not able to walk through the rock. And that's because we've added collision shapes for both of them. The player has one around his body and the rock has a circular one all around it. We also didn't add a collision shape to the player's head. And the reason for that is, well, kind of clear here. We don't want him to stop when he gets to this point because it's a 3D, well, it's a 2D game, but in a 3D world. So the player should be able to move closer to the rock. It's just being drawn in the wrong order. The order of drawing is determined by the order of these nodes in here. So if we just swap the player and the rock around like this and run it again, when I go in front of it now, the player is drawn on top of the rock. So we can see more of a depth to the game. There is a smarter way of organizing this, and we'll use that later on, but for now, this will do pretty well. So this gives us the basic functionality we wanted. However, the rock that we've got here is a little bit restricted. And that's because the image that we've used in the Sprite 2D is the stone image. So what if we do want to come back and create other rock types like gold, coal, iron? Well, we could just create multiple scenes. So we could rename this to rock_stone and then create another one, which is rock_silver, and it'll use a different image. But that's quite inefficient because the result is that we create multiple scenes which all pretty much do the same thing. We actually just want to keep the scene as it is, but allow it to change the type of image and the type of data that's associated with it. And we can do that using resources. So let's go into our script and just create a standalone script. So this isn't going to be attached to any scene. It's just going to be a script on its own. We select create new and create a script. It's going to be inside the scripts folder, and the name we'll give it is rock_data. So we'll go back into the script here and make sure we select that one. It's by default just a very basic script, extends node, and has just the basic process and ready functions, but there's nothing inside of them. And that's fine. We don't actually need any of this because this script isn't going to have any real functionality. It's just going to contain data. So let's delete that and turn it into a resource by saying extends resource. Now Godot knows this is a particular type of script. The next thing we want to do is give it a class name so that we can identify it easier later on. So the class name is going to be rock_data. And then we're going to define some variables that are going to be common to all of our different rocks. So regardless of whether it's gold or stone, they're all going to have some kind of properties. They're just going to be different depending on which ore or rock type it is. So let's define these properties. We can say var texture, first of all, and this is going to be a texture, texture 2D. Misspelled that. Texture 2D. So this will allow us to assign a particular texture to a rock, meaning that we can change what type it's going to be. But we also want to have different properties, like the health, which is how many hits it takes to break one of these. That way stone maybe is an easy one to break, but diamond needs multiple hits. How rare they are, and so on. But just defining them as variables here isn't quite enough. What we want to do is add at the start at export. And I'll show you what that does once we've completed this. So let's just create multiple of these export properties. The second one is going to be max underscore health, and this will be an integer. Then let's do another one, which is going to be the rarity. So this is how rare rock is going to be. Then we can also have minimum depth, so that some of them don't spawn until you get further down into the mines. So this will be min depth. And then the last one is going to be one that we haven't actually covered yet, which is ore underscore resource. And that is going to be our ore. So maybe we come back to this one because we're skipping ahead a little bit if I add that right away. The idea there is that these rocks are connected to an ore. So when the rock breaks, it's going to drop that particular ore. Or if a diamond rock is broken, it's going to drop an individual diamond for the player to pick up. So that's the last property, but we haven't really talked about that too much. I'm not going to add it in just yet. But now that we've got this resource, let's save it. And we can start using this basically as a template to create our different types of rocks. So in our assets folder, or maybe not even assets, inside of our root folder, we'll create another one called data. And inside of data, we'll create another folder, which is going to be called rocks. So here is where we're going to store all the different rock data. Stone is going to be the easiest. So let's start with that. We right click on rocks, we go into create new, and this time we're creating a new resource, which we haven't made yet. So this is a new type of object that we're about to create. This brings up a menu that allows us to select a whole bunch of built-in resources within Godot. But because we've just created our own one and we gave it the class name rock data, we can actually search for that here. There's our own resource, rock data. This is a custom resource that we've created, but can now be accessed when we create more of these. So click this button here, and we'll save this inside data and rocks. And you notice it has a different file type to what we've done previously. So our scripts have been .gd, but resources use .tres or TRES. So let's rename this to be our, I guess it's stone resource. And if we navigate to it and double click it, it will bring up a slightly different menu here. So this is our stone resource. And if you look at these properties, the first name is rock data. That's our class name. The ones underneath are what we've just defined. Texture, max health, how rare it is, and min depth. That's what these exports did. So by adding export at the start of the variable, it's basically exported that variable so that we can configure it and modify it in the editor. So let's start by configuring the stone. We'll basically do the same thing we just did with the texture. We'll create an atlas texture, open it out, go into our images, find the stone again, drag it over here, and then let's zoom out, set it to, that didn't work. Yeah, set it to that one. So that's our stone. But then we have other properties as well. So max health, well, let's say it takes 3 hits to break the stone. Rarity is not going to be super rare, so 50. The higher the number, the more common this is going to be. So basically this is saying if, for example, I had a bucket of 100, then 50 of them are going to be stones. It's not exact, it's not a percentage, but the weighting is given to the bigger number. And then the minimum depth is going to be 1. So we want stones to appear as the most basic rock, and they're going to be present at every level of our mines. So what do we do with this now that we've created it? Well, we can go back into our rock scene and go into our rock. Where is it? We don't have a rock script yet, but we can create a script for our rock. So we select this button, change the folder again into scripts, and save it in there. So now it's a pretty basic function. We can get rid of process actually. We don't need that at all. We will need ready, so we'll leave that in place. And then there's a couple of things we want to do. So this rock will need some variables, some properties. The primary one is that it needs health. So we briefly spoke about that while we were configuring the resource, but each of these rocks will take a certain number of hits with a pickaxe before they break, and that is the health. So we'll define a health, spell that correctly, a health variable, which will be an integer. And then we want a way of assigning a resource into this node. So we're going to use our exports again. We'll say export variable data is going to be rock data. So this variable is a type of that resource. And you notice very briefly, something just appeared over here. So now inside of our editor, we can assign a resource into this scene. So I can go into my data folder here, grab this resource, drag it over, and now it's assigned into this scene. So into this rock. And we can see what is inside it by just expanding it. So that's the texture, it's a stone, and it has this much health, rarity, and minimum depth. We can extract these as well. So if we go into our ready function, we can now say that the health of this rock is going to be data.max_health. And we can also take this texture and assign it onto our sprite 2D. So to do that, we need to have a reference into this node. We've done this already with the player. So we just click on this, drag it over, holding control. And when we let go, we're left with this sprite 2D variable. So let's take our sprite 2D, access the texture property, and then make it equal to our data.texture. So whatever resource we put in here, whether it's a stone or a diamond or an iron ore, whatever texture it has is going to be assigned into this particular rock scene. Visually, it's not going to look any different. Well, for two reasons. One reason being that we've used the exact same texture for the stones, but the other reason is that the changes within that script, they only happen when the game is actually executed. So this ready function will run when this rock is created in the code. In the editor, it's still whatever we assign to the sprite 2D. But let's test this out by creating another resource. So we've already created a stone. Let's go into our rocks, create a new resource, use rock data, save it in here as iron resource. Then, oops, I misspelled that. Iron. Okay, and then inside of this iron resource, we can apply basically all the same information. So we'll make a new atlas texture, but this time we use the iron ore image. So this will look different to the stone. So let's select, I think this top right represents so this will be the rock, and then this will be the ore that drops out of it. So we'll select this one for now. And then we can set the other properties. So it's going to be a little bit harder to break than stone. Let's say it has 4 health. It's going to be twice as rare. So 25 versus 50. And it will appear after level 3. So now we have our rock resource for iron. What we should be able to do now is go back into our scene here and replace the stone resource with an iron resource. It still looks the same here, but if I press F6 to run it, you can see it, but it's not a very good demo. Let me go into my level where everything is in the middle of the game. I now have an iron rock instead. So even though in my editor, this is a stone rock, in the actual game, it's iron. And that's because that's the resource that we assign to that rock. Now imagine in the game we have maybe 50 of these rocks automatically generated by the code. Well then what we can do is configure our script to randomly pick a resource and assign it to that rock. That way, we still only have one rock scene. So we only have this one node with its children. But the properties, like the sprite and everything else, the health of it and how rare it is, all of that changes depending on the resources. So the rock resources are almost done. We still have a bunch more to configure, but there was something I mentioned when I was creating the script for it. If we go back to rock data, I started typing an additional export variable and then said we'll come back to it. So that variable is going to be the ore that's linked to this rock. If let's bring up one of these resources. Where were they? Yeah, so if we go into the iron image, and select the region, that's what we've used for the rock itself that the player can break. But then when the player breaks it, we want to drop an ore, which is going to be one of these images. So I need to create another resource, basically. I need to create something else in the exact same way as I did for the rocks, but for these ores. The process is going to be pretty much the same. The only difference will be that they'll have slightly different properties. So they're not going to have max health because once the rocks are broken, the ores just appear. But see as an exercise if you can remember how to create another resource. So I'm going to do it myself now, but this will be for the ores. So what I would do is go back into my scripts. This is how I started with the rocks. I created a script for rock data, and then I was able to create resources of that. So let's do the same thing here. I'll create a new script, which is going to be called ore data this time. And we open up ore data, get rid of all of that stuff. And we'll say that it extends resource. We then need to give it a class name so that we can find it when we search for it in the resources. And this is going to be ore data instead of rock data. And then we just export a few variables. So the first one is going to be the name. So we need to actually call this something. So that's going to be a string like iron ore or diamond. Then a second one is going to be the texture. So that's basically the same as what we did for the rock. So texture is a texture 2D object. And then lastly, we're going to export the value. So we need to say how much these actually cost so that when the player collects them, some are going to be more valuable than others. Now we can save this ore data and we can start creating resources for our ores. Our current resources for the rocks are inside this folder here. So it's data, then rocks. So let's create another folder inside of data called ores. And inside ores, we'll create a new resource. This time it's not rock data, it's ore data that we need. And we'll save it there with the name of, let's just do stone ore for now. So we can expand it, bring up our stone ore resource, and we can start configuring it. So first we'll give it a name, stone_ore. Then we'll give it a texture in basically the same way as we've already done for the other bits. Atlas texture. Where's the image? In here, drag this over to the bottom, the atlas. And you could use, this is up to you at this point. You can use any of these ones. I think any of these four will look pretty good as individual ores. So this is what's going to be dropped when we break a rock. So I'm just going to pick the top left just for simplicity. And then lastly, we need a value. So let's say that they're worth 10 gold each. So if you go and collect 10 rocks and return to surface, you can sell them for 100 in total. So that's our stone resource created. Now we want to go back into our rock resource and link the ore into it. So if I go into my stone, so under rocks, my stone resource, there's no way to link it. It's not one of the export variables. All of those are controlled inside of the original script in here. So when I go into rock data, which is my resource for it, whatever export variables I have here is what I can then customize. So unless I add it in here, I can't add it inside of the editor. We'll create a new export variable here called var ore_resource. And this will be our ore data, which is actually the class name, remember? Just like this one is class name rock data. Our ore resource is ore data. So now when I save this and go back into my stone resource, a new property has appeared. And what I can do is grab the stone ore resource, drag it over and assign it here. So now everything is linked. The stone is the stone data for the rock is linked to the stone ore data. So when I break this one, it's going to drop this one. And because I've already created the same thing for iron, I know that if I don't do the ore now, I'm going to forget to come back to it later. So let's very quickly create a resource for iron ore. I think I can just copy this. Maybe I can duplicate it. Yeah, so if I right click and duplicate, let's see, and then change it to iron ore. I now have two resources, and I can modify my iron ore. So let's rename this to iron ore. And then we change the image. Oops, so that's still okay, but I need to load in the, where is it? The iron sprite sheet. And actually that updated automatically because the region is still the top left. So that worked pretty well. I didn't need to redefine the region. It's the same one that I used for the stone ore. So we minimize this one and the value, let's set to, we'll say double the price of stone. It's twice as rare, so let's say 20 for iron ore. Now let's just check that they are still different. So that's my iron ore and that's my stone ore. So that's good. Sometimes when you duplicate, it can link the two items together, but I guess that's not the case with resources. So they are unique and they have their own properties. Now I can go back into my iron rock resource and let's minimize that. I now have this unassigned ore resource. So let's drag over the iron ore. And now these two are linked. So whenever I break an iron rock, I'll eventually, and once I add the code to do it, I'll drop an iron ore. So that was a lot, but that's set up quite a lot of flexibility for us later on. And although we don't see the results immediately, we will be able to really improve our workflow later once we start adding more of these rock and ore types. Because we've already set up the foundation for it, creating more is much easier. And the best thing about it is that we still just have this one scene. So when it comes to writing code for it, we'll just maintain one script attached to one scene for the rock, but the resource is what's going to give us that flexibility to choose what type of rock it's going to be. So let's run the code one more time, just make sure there's no errors, and I've run the wrong thing. Go into the level so that we can see both the player and the rock side by side. Yeah, so everything still works. We don't seem to be getting any errors or any bugs. And we can move on to the next part. So now that we've got the player and the rock created, we can move on to the actual mining mechanics. We have the idle animation and a run animation, but we haven't got any actions yet. So the player can't actually swing a pickaxe. Let's address that first of all. So let's go into our player scene, select the animated sprite 2D, and then down here where we've got the different animation types, we can add on the mining animation. If you've been following everything okay so far, then you should be able to do this yourself. So if you like, you can try pausing here and adding the mining animation. So the way we'll do that is head into this add frames from sprite button, go into the assets folder, images and the player. And this time, instead of selecting the player sprite sheet, we go into player actions. Here, the sprite sheet is split into 2 horizontal frames, so we can change that number from 4 to 2, and then vertically, I think there's 12 of them. So we set that to 12. And now everything is positioned inside of each individual frame. This sprite sheet's really good. It includes a whole bunch of different actions, but for this game, we're not going to need the majority of them. We just need the 3 at the top, which are the different directions of swinging the pickaxe. So we'll add those in, but I've just realized I've kind of got ahead of myself here because I haven't actually created a new animation type yet. So let's click here and then create swing underscore pickaxe. That's how you spell it. Pickaxe underscore down. Then I just need to repeat that again for the other 2 directions. So let's create 2 more animations. Swing pickaxe right. And let me just copy this so I don't have to type it out fully the third time. Swing pickaxe up. Okay, so now I've got up, right, and down. Now I can go into this button here and hopefully it's remembered the settings, which it has. So for up, there's actually 2 frames for any of these. So this is the ones that I will select for swing pickaxe up. Then we'll do the same for going down. So that will be this one. Oops. So if you select one by accident, just click it again. It will deselect it and it will leave the remaining ones. And then we just need the one for the right hand side, which is this one. So we can test this out. Let's see how it looks. And it's okay, but maybe we can speed it up a little bit. So let's try 10 frames per second. In reality, I guess we're not going to be we're not going to be like constantly mining one after another. So let's untick this and we'll just get one loop. Yeah, I think that's okay. So this just gives a very quick swing of the pickaxe. So let's go with 10 frames per second. I don't need the animation to loop. So that's essentially what this button here does. So I'm going to turn off animation looping for all of the mining animation, because unlike idle and running, this is a single action. So as long as we're using the button to swing the pickaxe, it will run the animation once. And then we have to do the process again if we want to swing the pickaxe a second time. So that means that for all 3 of these, we untick the animation looping and set the frame rate to 10 frames per second. Now that I have the animations, I need an input key. So right now we've got controls for moving the player, WASD, but we need to add something to be able to actually activate this mining and swinging the pickaxe. So we head to the project settings, go into the input map again, and we've already got what we configured previously. So we add a new action, which is going to be use_pickaxe. And I will set this to be the spacebar. So depending on how you want the controls in your game, you can change all of these, but this is what I'm going to be using for my version of it. So now we need to link that action, the spacebar, into playing the animation. So we go back into the player script, and inside of our physics process function, we can add in this additional check. So we'll do that before we run the other 3 functions. So right at the top here, I'm going to add a comment to say handle mining input. And for input, we're just going to be checking for, well, we've actually done it before. For movement, we've taken input previously. So I will say input, but this time the function we want is _action just pressed, which is this one at the top. The action we want is the one we just created, which was use pickaxe, which is this one. So as soon as that's pressed, i.e. I press a spacebar, then we're going to activate the mining animation. So we'll call a function here, which will be use_pickaxe, which we now have to go and define. So further down underneath all of the movement and animation functions, let's create another one, which is that use_pickaxe function. It doesn't return anything, so we'll just add void at the end. And for now, all this one needs is just to play the animation. So it will expand over time with all the other functionality, but right now we just needed to get the animation started. So let's copy that into here. And the animation type that we want is the one we've just created, which is swing pickaxe. So let's test this, press F6 to run the game and see what happens. So when I press spacebar, nothing seems to happen. If I press it quickly though, you can see that the player kind of judders and gets into a little reset of an animation. So there's actually something subtle going on here. Inside of our physics process, we first of all check for this input, and then if there is a spacebar pressed, then we play the animation for the pickaxe. But then immediately after that, we process movement. And this will check the direction and velocity. After that, we go into process animation, which defines, based on the velocity, whether or not we should be using run or idle. So basically what's happening is we say to Godot, we want to run the swing pickaxe animation, but then immediately after that, we change our mind and we say, no, actually, the player is running or the player is idle, so play that animation instead. That means that we need a way of knowing if the player is moving idle, or mining. So right at the top, we're going to create a new flag. That will be a variable called is_mining, which will be a Boolean, and it will be defined as false to begin with. Then once we've pressed the spacebar and we've run this use pickaxe function, before we even play the animation, we want to set isMining to true. And then back inside of our physics process function, after we get this input, but before we get into all of the movement and other animations, we're going to add a simple check here. This will have a comment to say skip movement if mining. So we can say if is_mining, then first of all, the player shouldn't be moving. So the velocity is set to vector2.0. And secondly, we just want to exit this function. So we'll say return. We don't really need to continue processing everything else afterwards. So the result here is that we're not going to change from one animation to another. As long as the player is mining, he's going to continue with the mining animation. We're not going to run this code subsequently. So let's test this out now. And I just move over here, press the spacebar, and now we have played the mining animation. But I can't move, I can't do anything else. If I press spacebar again, I can restart the animation, but the player is basically stuck now. And the reason for that is that once we set this variable to true, we're never setting it back to false. So when the mining is finished, we should say that the player is no longer mining. So how do we tell if the player has finished mining? Well, we can just do that from the animation. Basically, if the mining animation is finished, then the player has finished mining. The pickaxe has been swung, and now we can go back to normal. And to do this, we can use signals. So with the animated sprite 2D selected, we switch from the inspector node from the inspector tab over to the node tab. And under here, we can see a bunch of different signals. Specific to the animation type, we have animation changed, finished, loop, etc. The one we're looking for is animation finished. So if we double click this, we can then select our player and connect it. This automatically creates a new function at the bottom here. And the way this function will work is that as soon as the animated sprite 2D finishes the animation, it will send a signal into this function, or rather into this player scene. And this function is what then processes the output. So what we can do here is say if isMining, meaning isMining is true, then isMining becomes false. So it basically just reverts it back to nothing. So as long as the player was mining at the time, they're no longer mining because the animation is now finished. So now if I test it out again, run over here, press a spacebar, once it's finished, I go back to the idle state and I can move around again. So this is actually working pretty well. The player script, however, is going to start becoming quite busy over time. There's going to be a lot of different functions. So I would like to start separating things before it gets to that stage. And I'm just going to do that with comments. So before we get into this process movement function, I'll add a comment to say movement and animations. And then I can even add lines as these comments as well, just to emphasize that this is a specific section. And then further below, where we've just added these new functions, let's add another section that says mining. So at least now I can see at a glance what section of code I'm looking at here. So if we go back into our level where we've got the player and the rock and we run this script, everything here is okay. And we now have the mining animation, but there's no actual interaction between the player and the rock. So that's what we need to add in next. In order to be able to detect when the player has collided with the rock, or rather the player's pickaxe has collided with the rock, we need to check what's in front of the player. So let's change the player into a different mining animation. Let's go with this one and then change the frame to the next one, which is where he's actually swung the pickaxe down and hit the ground. So back in the level, I can now see them side by side, the player and the rock. Although the pickaxe has been swung, it is just a 2D image. So there's no actual detection that it's hit this rock. What we can do is create another collision shape in front of the player. And that's going to act as our detection box for the pickaxe swinging into a rock. We head back into the player scene and we add another child node but this time we're going to use an area 2D, which from the description down here says it's a region of 2D space that detects other collision objects entering or exiting. That's exactly what we need, because the rock itself is a collision object. It's a static body 2D. Our area 2D isn't going to physically collide with it in the sense that it won't be able to move through it, but it will detect if there's an overlap. So we'll rename this to be called Hitbox, and then we'll add another child, which will be a collision shape. So it's actually going to have its own collision shape. We're going to use a rectangle for this, so let's head over here, set up our rectangular collision shape, and we'll reduce the size quite a lot. So let's put it over here. We'll link it to the player, reduce it to just about a similar size as the player itself, or the player's collision box, and then we bring this all the way back in. So that's kind of done by sight, but if I head over to transform, I can manually set these numbers. So for the width, I'm going to set it to 8, and for the height, I'll leave it as 5. Although actually looking at that again, that is the position of it relative to everything else. So when I move this around, these numbers change. That's not actually the size. For the size, we need to click on the shape itself, and that brings up this size menu. So the width here is going to be 8, and the height is going to be 5. Now I can go into this position and adjust this. The position itself, it can get a little bit confusing, because while we're moving this around, we're actually moving it relative not to the player, but to the hitbox, this area 2D. And when the player turns, looks to the left, up or down, we need to be able to move this collision shape around with it. So I actually don't want to mess around with the position too much. Instead, if I select the hitbox, you'll see that this has gone red. So if I go away from it and come back, this dot here changes red, it's highlighted, because this is the hitbox that we can actually control. And it's that hitbox that we want to move in front of the player, not the collision shape. So now we select the hitbox, go over to transform, and change the X coordinate to 10. And now that moves in front of the player towards the pickaxe. But of course the collision shape is now away in front as well. So let's go back to the collision shape, change the transform position to 0. Now it is sitting directly underneath our hitbox, so it is positioned correctly, albeit a little bit low. So let's change the Y position to 4. The advantage of doing it this way is now if we want to move this, let's say the player turns to the left, if I select the animated sprite and flip H, the player is now facing to the left, but the collision shape has stayed where it is. So then all we would do is take our hitbox and change the position from 10 to -10. And now it's moved to the other side of the player. So by offsetting the area 2D, the hitbox from the player is how we're going to be able to adjust for the player's movements. Although I've realized that we have a little bit of an overlap this direction, but we don't have one when I go in the other direction. So what that tells me is that this collision shape of the player is actually off center, which it is. So we can fix that while we're here, and that's a little bit of a side mission. And maybe just bring it in a little bit to 12. Great, okay, so now there's no overlap and we've got our 2 different collision shapes. The problem with this collision shape though is that although I can change the position of it manually in the editor, I'm not going to be able to do that live. It's going to be static with these numbers. And let me show you what I mean by that. So if I just press F6 to run this, I can't really see those collision shapes. So I don't actually know where it is. But if I head over to debug and select visible collision shapes, and I press F6 again, now I can actually see those 2 shapes. So this one is looking fine. And when I press spacebar, the player mines and the collision shape is in the right place. But if I go left, it's still on the right hand side. So I need to change this X coordinate within the code. The same will apply when I'm moving up and down. In this case, I need to not only change the X coordinate, I also need to adjust the Y coordinate and rotate the hitbox. So we're going to have to do some modifications to this position variable here inside of our code on the fly. So we head back into the script and we'll go back up to the top of the player script. The easiest change is going to be when we go left and right, because we just flip this number. However, the code needs to know what this number is at the beginning. So let's create another variable, which is going to be called hitbox_offset, and that will be a vector 2. Then we will need a ready function. So I must have deleted it previously. So above the physics process, we'll define our standard ready function. Doesn't take anything and doesn't return anything. So we'll add void at the end. And then we'll take this hitbox offset and then we'll assign the numbers to it. So this 10 and 0 need to be stored inside of this variable. I could type the numbers manually because I know that they're 10 and 0, but I would rather pull them directly from here just in case I ever change this to 12 and I forget to update the numbers in the variable. So what I will do instead is grab the hitbox, drag it over holding control, and now I have this hitbox variable. So we take this, put it in here, and we extract the position. So let's just add a comment to remind ourselves what this is. We initialize the hitbox offset. So now as soon as the game begins, we have a variable that says that the hitbox is offset by a coordinate of 10 on the x-axis and 0 on the y-axis. I now need a function that's going to handle the position changes depending on the player's direction. So let's go down to the bottom. We've got our movement and animation. Maybe above mining, we'll add this comment block which says hitbox offset. So this is going to be another section where I'll create the functions for this. I'll start by making a new function which will be update hitbox position, which also doesn't return anything. And what I will do for simplicity is I will extract these two positions into individual variables. So we can say that x is going to be our hitbox offset from before, but just the x property of it. And then the same for the y property. So then whenever I run this function, my variable x is just going to be 10 and y is going to be 0. So it'll be easier for me to work with them rather than typing this out fully. Next, we just need to adjust the hitbox position based on the player's direction, which we actually know already because we have a global variable called last direction. So whichever direction the player is or was moving in, that's the direction that they're facing. So what we could do here is say if last direction is equal to vector 2.left, then we will do something. So in this case, we're going to flip the position of our hitbox. So we'll say hitbox.position becomes a new vector 2. And the only difference, if we take these x and y coordinates from before, the y coordinate is the same. It was already 0. The x coordinate is just a negative version of the starting coordinate because now the player is facing left. So this becomes negative x and y. Then I can say elif last direction is equal to vector 2.right, which is actually the player's starting position. Then the hitbox position becomes vector 2, and it's just x and y. So it's basically just the original hitbox offset. We'll come back and we'll add the up and down later, but let's just test out that left and right is working first. So we've created a function, now we need to call it whenever the player moves. And that should be inside of our process movement function. So we change the direction, calculate the velocity, record the last direction, and then we can call this update hitbox position. I think this should work at this point, so let's just test it out. Run to the right hand side, that's fine, go left, and there we go. The box flips over to the opposite side. So now when I mine, the hitbox is facing in the right direction. I go right, it switches again, same for right and left. So that's already working pretty well. And what we need to do next is add in up and down movement, which is going to be a little bit trickier. But before we do that, this has already got 2 if statements inside of it. So I will add another 2 for up and down. And there is a neater way of doing this. If I need to check for various different conditions, I can just use match. It does basically the same thing, but it's a little bit neater. So we'll say match our variable, which is last direction. And then rather than saying if it equals to this, then do that, we just get rid of the entire if statement. Instead, it just says match the variable to vector left. If it matches, then this is what we do. Then, if it's not that one, match the variable to vector right. If it matches, then this is what we do. Exactly the same functionality as the multiple if-else, but now we don't need them. We just write out the different conditions that we're checking for, and then what happens if they're met. So let's do vector 2 up and vector 2 down. So we'll just copy this down here and rename them. So we've got up and we've got down. When the player is facing up, then it means, let's just run it again, then it means that we want the hitbox to actually be in the middle. So the x coordinate will become 0, which is currently our y coordinate, and the y coordinate will become negative x, or negative 10, which is the negative of our x coordinate. So actually all we're doing is just flipping these two around and then making one of them negative. So go back into our script, and for the up direction, we now say it's y minus x, and for the down direction, it's negative y and x. No, sorry, I don't need a negative here because the y is always going to be 0 based on these parameters here. So let's test this out and see what happens with the other direction. So if I run down, that's actually worked. So the hitbox has moved from being to the right to the bottom, and then the same for up. The problem is though, when I'm turning right and left, it's horizontal. When I go up and down, it's still horizontal. So it actually needs to rotate 90 degrees. But this is where it gets a little bit tricky and why we have this separation. So we're moving the hitbox, but we're going to be rotating the collision shape. And I'll show you why. If we select the hitbox, head over to rotation, and let's just start turning it. You'll see that what it's actually doing is rotating our collision shape around the origin of the hitbox, which is not what we're needing here. We just want the collision shape itself to rotate around its own center point. So this is the rotation that we need. We rotate it 90 degrees, and then because the player is facing up or down, the hitbox is going to be moved up or down. So this is the effect we're aiming for. Let me just undo those changes. And now we can head back into the code and adjust the rotation on the collision shape. But currently we only have access to the hitbox, not the collision shape. So we head back up, drag over the collision shape as well, hold Control, and now we have a new variable that directs us into this node here. So if I copy this name, go down into my function here, and once I've adjusted the position, I also need to adjust the rotation. So we'll say dot rotation underscore degrees is equal to 0. The left and right is not going to be rotated, it's just going to be flat. However, there is a little issue or potential issue here. I have two collision shape nodes inside of this scene tree. And because I've got a variable called collision shape 2D, it's not immediately obvious which one it actually is. So what we'll do is go back up to the top where I've dragged over this one and just give it a little bit more context. So I'll add hitbox underscore at the beginning. So now it's a hitbox collision shape 2D. So now I know exactly what it's referring to. Now we need to go into the function and rename this to hitbox underscore collision shape 2D, and that gets rid of the error. So let's just copy this, paste it down for right, but then when it comes to up and down, we need to set it to 90 degrees. So we'll paste this in here as well and set that to 90 degrees. If I test this out again, I should now be getting this rotation. So now it's actually working pretty well. If I go down, swing the pickaxe, up, swing the pickaxe, the collision shape is directly in front of the player. So that's working pretty well. No matter what direction we're running in, we can adjust the collision shape position and rotation so that the player is going to mine in that direction. So that has now given us a way of detecting a collision between the player's mining animation and potential rocks that he can break. And it's rotating all the way around, so that's all working pretty well. However, we're not actually checking for any collision yet. So that's the next thing that we need to add in. So now how do we check for this collision? Well, if we head back over into the player scene and go into our area 2D, we switch over to the nodes tab. We've got a whole bunch of different signals that we can use. One of these signals is body entered. So that's going to tell us when a body, in our case a static body 2D, which is our rock, comes in contact or enters this area of the area 2D node. And that's exactly what we need. So let's select the body entered signal here and add it onto the player script. And that script or that new function should appear right at the bottom here. So it's inside of our mining section, which is good. And this is going to tell us that we've detected a collision. The problem though is that it doesn't necessarily limit it to just the rocks. It's actually going to detect collision with any body that enters it. And in this game, we will have other things apart from rocks. So we need to be able to tell the difference. The easiest way to do that is to define what a rock is. So if we go into our rock script, right at the top, we can add a class name. So we'll say class underscore name is rock. So if I save that, this scene and this script is now associated with the name rock. Now, if we go back into the player script, and in here we can say, once we've got this collision, you'll notice that inside of the function, it actually gives an argument, which is a body. So because this is checking for a body entering the area 2D node, it will tell us which body it is. So for now, let's just print body. Let's run this. That's the wrong thing. We need to run the level. And when we enter, actually, you notice it does a few different things. So as we're running around, because there's a tiny overlap between the player's collision box and the mining collision box, it's actually telling me here that it's detected the player has entered the mining area. So that's another reason why it's important for us to be able to differentiate between different objects. But if I head over here, you'll see that it's detected the rock. And there's various properties that we can extract from this body. So we can ask what the body's name is. We can say if body.name is equal to player, or if it's equal to rock. That's one way of checking. The problem is that that only works if you have one single object with that name. But when we have multiple rocks, it's going to be called rock, rock 2, rock 3, rock 4. So this is only actually going to work for a one-off case. Instead, what we can do is just get rid of that and say if the body is rock. This seems like a pretty simple piece of code, but what that's basically saying is check the class type or the class name. The class name is rock. So if the body that we've encountered here is this, well, that means that it is the scene. It doesn't matter what it's called, it's always going to be this object. And that makes it much easier. So now we can print the body again, and I keep running the wrong thing. So if I go back to the level, run that, now you see we don't get that detection from before with the player. So it is detecting it, but it's not a rock, so it's discarding it. It only gives a print statement as long as we have this collision with the rock itself. But now there's a slightly different issue, which is that this detection appears as soon as the player interacts with this rock. So I haven't actually swung the pickaxe. If I hit the spacebar, this is the point when I should be able to check for collision. But the collision is being checked constantly. So what we need to do is turn that hitbox off and on as we need it. So if I go back into the player and select the hitbox, there is a monitoring property here. And when that's on, the hitbox is active. When it's off, the hitbox is not active. So I can adjust that basically by turning it off until the player actually swings the pickaxe. So let's go into our process animation function. And right at the start, we're going to disable the hitbox. So I'll add a comment to say, disable hitbox until player swings pickaxe. Realistically, this could go into other functions, but the reason I'm adding it here is because it's tied to a different animation, which is the mining animation. So what we'll do here is we'll take our hitbox, which we already have a variable for, and we set the monitoring to false. And since this function runs pretty much constantly inside of physics process, it basically means that the monitoring is actually going to be turned off all the time. The time that we do want it to be turned on is as soon as we use our pickaxe. So when we press spacebar, this function is fired, then we want to turn on the monitoring. So I go into my use pickaxe function, which is right down here. I set is mining to true, and then I take that hitbox, take the monitoring property and set that to true as well. So now let's go back to the level and test this out. Head over here. Now I'm not getting any print statements, even though there is an overlap between the area 2D collision box and the rock. As soon as I press spacebar, it's detecting that it's hit the rock. If I go over here, do the same, there's no collision. go back, do it again, and every time I hit spacebar, I'm getting this collision detected. And while this is actually working really well, there is going to be eventually an issue here. So let me demonstrate by adding a bunch more rocks. I can just take this rock and duplicate, or just Control C, Control V to just make a bunch of extra rocks. And I'm going to move them to be pretty close to each other. Not overlapping, but close enough. So now if I run the game again and see if I can position myself carefully between them such that I'm overlapping two rocks at the same time, which is a little bit tricky actually. I should have made the collision box bigger to demonstrate this. Am I going to be able to do this? Maybe here? Yes, it is working here. So the collision box from the pickaxe is overlapping two different rocks. And now if you pay attention here, if I press spacebar, it's detecting rock 2 and rock 4. So it's actually detecting collision with more than one object, which is how it's supposed to work. But in our mining game, we should only be able to hit one of the rocks at a time. And the rock that we want to hit is the one that is essentially closest to the hitbox. So that's the one that's overlapping the most. So the way we're going to approach this is by splitting up into different stages. First of all, back inside of our player script, right at the top, we need to track all of the rocks that have been detected. So let's add a variable called detected rocks, which is going to be an array. And I didn't type that one, so let's say it's an array and it starts off as an empty array. And then when we detect collision, so down here, instead of printing out the body name where we're seeing more than one, what we want to do is add all of the overlapping rocks into that array. So we'll take our detected rocks array, say .append, and what we're appending is any body that is collided with the collision shape. So most of the time this is going to be just one rock, but as I just showed in that example, there could be more than one if it overlaps. And this allows us to keep track of them all. However, this means that over time this array is just going to get filled up. So we need to make sure that we clear it fully every time we swing the pickaxe. So let's grab this array, and then when we swing the pickaxe, we're just going to run clear on it. So we start with a fresh slate. Every time I swing the pickaxe, there are no detected rocks. Then I check for collision, and as long as the body that's collided with is a rock, then I add it to that array. Doesn't matter how many it's collided with, all of them, well, one or all, are going to end up in that array. And now that I have this array and I have all the rocks stored inside of it, I can check which one overlapped the most. And then I'll prioritize that one and say that's the one that the player hit. I'll do that check once we've finished mining. And that actually happens inside of this original function, the one that checks when the mining animation is completed. So we just say if the player's mining, he's no longer mining. Well, in addition to this, we're also going to check how many rocks were hit. First, we need to check that there was at least one, because we could just swing the pickaxe and hit nothing. So let's say if detected rocks dot size is greater than 0, well, it means that we've detected at least one rock and we've added it to the array. If it is, then we need to detect which of those rocks, if there's more than one, which of those rocks it is that we want to prioritize. So we'll add a new variable called rock to hit, and this is going to be determined by another function. So we need a function that's going to check the distance between all of those rocks and the hitbox. So let's come back to this and actually just comment it out for now to get rid of the error. And instead, underneath, let's create another function, which is going to be get most overlapping 2p's overlapping rock. So this doesn't take any arguments, but this time it actually does return something. So here, instead of void, I'm going to return a rock, because remember that is the class type of our rock object. So it's going to detect which one it is, and that's what it's going to return. So inside this function, we need to start off with an assumption that the first rock in that array is the best one, is the closest. So let's say best underscore rock is detected rocks at index 0. So the very first one, which there might only be one, then that's the best one to start with. Let's calculate the distance by saying var best underscore dist is our hitbox dot global position dot distance to. So by using this function, it automatically calculates that distance. I don't have to subtract it myself. And the distance that I'm checking is the distance to the best rock. So we'll say best rock dot global position. I realized that when I commented this out, it hasn't gotten rid of my error. So let's add a pass up here. Okay, so now this error is okay. It's because we haven't returned anything yet. So we'll continue defining this function. But we now have a starting rock and we know the distance to it. So now we need to go through all of the rocks. So say for rock in detected rocks and then calculate the distance to those. So var dist is equal to actually the same line from up here. I can just copy this down, but make sure to change best rock to just rock, since that's what we're iterating here. If then I find that there is a rock with a smaller distance, so if dist is less than best dist, so I've actually found a rock that's closer than the first one, then this becomes my new best one. So best dist becomes dist, and best rock becomes rock. So this is now my new favorite rock. I realized on typing this all out, the variable names are maybe a little bit silly. I could have just called this closest rock, but best rock in this scenario just means it's the best candidate. So now that we've got our best rock, it is the one that's closest, it's overlapping the most, then we can return that. So out of all of these at the end, we'll say return best rock. So after going through this entire function, we will have the one that's closest. So we can now go back up here where we commented this out previously, and the rock to hit is get most overlapping rock. And then once we've done that, let's print it out and see if we can test this. It could be a little bit tricky to get everything lined up again, but let's just see what happens. So first there's nothing. If there's one, then that's okay. So that's rock 3 down the bottom. Rock 1 might be easier to come from above. So now it's hitting 2 rocks, but it's only detecting rock 4. So let's see which one that is. Yeah, I kind of expected it was this one. It seemed like I was closer to the right. So let's try again. I think maybe I'm closer to the left this time. It detects rock 2, and that is this one here. So that's actually working pretty well. I can visually see that it's detecting the one that is overlapping most with my collision shape. So now I'm not going to be in a position where I can have basically a bug where the player can hit or break 2 rocks at the same time. But that is now the collision system pretty much configured for the player and all the rocks. So we can then start moving on to the next part, which is where we can actually do damage to them and break the rocks. So now, how do we actually break these rocks once we have this collision detected? Well, if you remember, when we created the rocks initially, they had various properties depending on the type of rock. So the iron has a health of 4, stone has a health of 3, and then we'll add other ones with different healths as well. The idea is that the health variable is how many times the player has to hit this rock before it can break it. So let's go back into our player script, and right at the top, I'm going to create a new variable. And this variable is going to be, let's say, pickaxe underscore strength. This will be an integer, and it will be set as 1 to begin with. So throughout the game, there's going to be opportunities to upgrade the pickaxe so that you can do more damage. But to begin with, it will just do 1 damage each time. So that's how an iron rock will take 4 hits. But then when this is increased to 2, an iron rock will only take 2 hits, and so on. So now that we have the strength and we know when a rock has been hit, because where is this function? In here, we're detecting our best rock, the rock to hit. We need to now link these two things together so that that particular rock that we've picked, this variable here, actually takes that damage. And that's actually going to happen inside of the rock itself. So we go into the rock script, which at the moment is pretty basic, but this is where we're going to add the functionality. This way, the rocks will take care of their own logic. So underneath our ready function, let's create a new function which we will call take_damage. Then inside the brackets, we need the amount of damage it's going to take, and this will be an integer. And we don't return anything, so we just add void at the end. And what we want to do here is just reduce the health. So we already have the health from this property, max health. When the rock is created, the health variable is taken from that property. So we can just say health minus equals amount. So it just gets subtracted by whatever amount of damage is being done. And just to test it, let's say print health. So now we have this function, but we need to actually call it. So back in the player script, instead of printing out the name of that rock, we're actually just going to take that rock directly and call the take damage function. And inside we can pass in the amount of damage, which is the pickaxe strength. So let's go into the level, press F6 and try this out. So that's got a health of 3, 2, 1, 0. So that is working pretty well. Obviously it can continue into negatives, which we need to deal with. But if I go to a different rock, that has its own health. So it's working pretty well. Every one of these rocks has its own independent logic and its own independent health properties. So now let's deal with this issue of negative health. What we want is to go back in the rock script and add something else. So once we take this damage, that's fine, it reduces the health. But when we get to 0, we actually need to destroy the rock. So let's add another function, which is going to be called, let's say underscore destroy. It doesn't take any arguments and doesn't return anything. So this function here, let's just pass for now. And let me quickly explain why I added an underscore here, but not here. And the ready function does have an underscore. The reason for this, it doesn't really impact the game at all. I could just avoid using underscores. It will still work in the exact same way. The purpose is to make a differentiation between the different functions. So if there's an underscore, that means that this is a function that is just called by the script itself. However, if there's not an underscore, that indicates that this function can be called from other functions or from other scenes and other scripts, which is exactly what's happening here. Take damage is being called from our player script over here. So that's why it doesn't have an underscore. But destroy is only going to be called inside of the rock scene itself. So it can have an underscore. That said, I myself am not 100% consistent with this, mostly because I forget. A lot of the time I just don't put an underscore, carry on as normal, and then I realize that function isn't actually used anywhere else except for that script. So it's a good practice to follow, but it's not going to break your code if you just call it destroy or underscore destroy. As long as when I'm calling that function, I call it with the same name. So if it has an underscore, then it needs to be called with an underscore. But what we want to do now is instead of printing, well, I guess we should still print the health as well, just so we can monitor what's happening. But then we can say if health is less than or equal to 0, then we want to destroy the rock. So we'll call the destroy function. And what the destroy function is going to do is basically delete the rock entirely. So to do that, we just need to pass q_free. This is the function you use whenever you want to delete an object or a node from a scene. What it essentially does is it adds this rock, it will add it to a queue, and when it's safe to do so, it will delete all of the objects that are inside of that queue. So this should actually be enough to test this. Let's press F6, head over to one of the rocks and just start hitting it. And there we go, the rock has disappeared. So that is working pretty well. As soon as we get down to 0, the rock is destroyed. Now, one little thing that I think would be a quality of life improvement is how the pickaxe action is actually deployed. So right now I have to keep pressing spacebar. So every time I press spacebar, it's going to swing the pickaxe and hit one of these rocks. But in this game, there's going to be loads and loads of these rocks. So I actually just want to be able to hold spacebar and continue mining instead. So to do that, we're going to change the logic a little bit. We head back into our player scene and add a new node. And this is going to be a timer. And we rename this timer to be the mining timer, and we'll configure some of its properties here. So the wait time is essentially like a cooldown. So it's how long between, if I'm holding down spacebar, how long between individual mining actions. So let's make this 0.5 seconds. And also the timer, once it runs out, it shouldn't just keep going. So it's a one-shot timer. Now we can use this timer inside of our player script to actually control how quickly the mining animation, or not the animation, but the mining action is executed. So we'll go into use pickaxe, and as soon as we start to mine, so as soon as the pickaxe is used, then we're going to start that timer. So before we start the animation, let's take the timer, although we need a reference to the timer first. I skipped the step there. We go back up to the top, drag this over, holding control, and now we have a variable that links to that timer. So I can use this variable back in the function here to say .start. So let's add a comment to say start the cooldown timer. And now we only want to be able to start the action as long as this timer is not running. So once it stops, we can use another swing of the pickaxe. So we go back into this function, our physics process, and this is where we're currently checking for mining input. But we're going to change this from is action just pressed to is action pressed. The difference is that it's not checking for just a single key press. It's going to detect as long as that key is pressed and held down. So I need a second check here, which is and mining timer dot is stopped. And I think that should be it. So if I save everything, save this as well, and then press F6. So if I now hold the spacebar, now it's a continuous action. So now the player will continue mining as long as I'm holding spacebar instead of me having to, I can still just let go and press spacebar, so that's okay. But it means I don't have to keep pressing it. I can just hold, and every 0.5 seconds it's going to swing the pickaxe again. But what is now missing from all of this is that when the rocks are broken, they just disappear. Nothing actually happens. Ideally, we want to drop something. So when iron rocks are broken, they're going to drop iron ore, and so on. And that's what we're going to work on next. So now we can start creating these ores. We'll start off with a new scene, and we'll select the Area 2D node. Then I'm going to rename this to ore, and as all Area 2D nodes, they need a sprite and they need a collision shape. So let's add a couple of child nodes. The first one is sprite 2D. There's no animation, it's just a static image for the ore. And the second one is a collision shape 2D. Now the ores are going to be automatically generated by the code. I'm not going to place them in the scene myself. So it doesn't really matter what I use too much in the configuration here. But just so I can visualize it, I'm going to create an atlas texture. And then this one will be a stone. So let's go into our stone, drag this over into the atlas, and then how do we do this? Adjust region, zoom in, and previously I'd chosen this down here for the rock, but now when that rock is broken, it's going to drop one of these stones. So you could choose probably any one of these four, but I'm going to go top left. So that gives me the ore image, and what that allows me to do is to set the collision shape accordingly. So this time we're going to use a circle, just like we did with the rocks, and just shrink it down a little bit. Yeah, I guess that's probably quite good here. Again, it doesn't have to be super accurate down to the last pixel. And for now, that's actually all we need. So let's save this inside of the scenes folder as ore.scene. And then what we can do is whenever a rock is broken, it's going to create the corresponding ore automatically. So let's head back into the rock scene and specifically the script. And we need to go into the bottom here and create a new function. This function is going to be called underscore drop underscore ore. Doesn't return anything, but what it does need to do is create an ore. For it to be able to do that, it needs to know what an ore scene is. So we're going to preload that into our script. So right at the top, I'm going to add a constant, which is going to be ore underscore scene, and we'll use preload. So whatever we put in here, and you can see it's pre-populating all of the different files in my system, whatever we choose here is going to be preloaded and assigned into this variable. So I need the ore scene. So let's see, underneath my scenes folder, there it is there, ore scene. Then we can use that as soon as we need to drop an ore. We'll say a new variable, which is called ore, is going to be the ore scene dot instantiate. So just like when I click this button usually to instantiate a child scene, this is also going to instantiate a scene. It's just not a child yet. So right now this scene will exist, but it won't exist anywhere in particular. Once we have that, we need to assign a position. So ore.position is just the position of the rock. So wherever the rock was, we're going to replace it with a piece of ore. But then we need to place this ore in the actual scene somehow. So the rock is going to be destroyed. It will disappear. But if we go into our level, this is where the rocks live. So we've got the level, which is kind of like the organized section. Then we've got the player and multiple rocks. So inside of the level is where we want to add the ore. And there's a couple of different ways we can get a reference to the level. But we know that a rock is a child of the level. So we can just look at the rock's parent. So what we can do here is say var level underscore root is equal to get underscore parent. So it's telling us that this is the rock scene, that's where the script is. The parent node is the level, so that is our level root. Now we can take the level root and we can add a child to it. And the child is going to be this new ore scene that we just created. So basically what it's doing through the script is the rock will create a new ore, and then it will select the level and it will click this button for us to instantiate a child scene. And that's going to be the ore scene. So it basically does all that inside of code. But things are going to get very messy if we do this. You can already see that I've got 4 different nodes here for the rocks. But in reality, in the game, I could have 20, 30, well, as many as you want, really. And the same is going to happen with ores. We're going to be adding a bunch of ores into the level. So we want to keep some kind of organization here. What I'm going to do is add little containers. So underneath the level, let's add a child node, and it will just be a node 2D. So not a node, but a node 2D, the one with the bluish purple circle. So that's one, and we'll rename this to rock container. And then we'll create another one, the same node 2D, we'll rename to ore container. So what we can now do is grab all of these rocks from before, move them all inside of our rock container. Visually, nothing should change. They're still exactly the same, but they're now organized inside of one container. And we have the same thing with the ore container. So we'll add all of the ores that we create into this node. So back in the script for the rock, we do need to make a few changes here. First of all, this level root. So now, remember, get parent just looks at the current scene and gets the parent from that. In this case, the parent for the rock is now rock container because we've moved it inside of this group. So to get the level root, I have to go up another level. I have to get basically the grandparent of this node. So the parent is rock container and the parent of that is the level. So we can just chain these and say dot get parent again. So that brings me to the level root, but then from the level root, I need to get access to the ore container. So we can't immediately add a child just yet. Instead, what we do is create a variable called ore container that references our level root, and we use get node ore container. So it's just a little bit of navigation. We get the level root, then we'll look for the ore container. That becomes the scene, or sorry, that becomes the node that we want to add our new ore into. So we replace this section with the ore container. And I think that should be more or less it. So we can now take this function and call it just before we destroy the rock. So we'll drop the ore first and then we'll destroy it. And I should be able to test this. Let's just see if we've got any errors. So we'll head over here and break this rock. And in its place, we've now got a stone. So that's worked pretty well. And there's actually something else we could see in the scene tree over here. So if I run this code again, you can see there's two buttons appearing. Local is what we already see previously. That's how we work with our scene. But remote shows us what's currently happening. So it actually shows the current state of our game. So everything looks normal. The ore container is empty. That's why doesn't have a little arrow to expand it. But let me go and break one of these rocks. This one here. So you notice that one of the rocks disappeared, and now the ore container can be expanded and it contains an ore. So we know that the logic we just added is working correctly. It's keeping things grouped as we intended it to. But there was something that's not immediately obvious there, and it's, I think, because of the collision shapes. So if I hide these and run it again, all of these are iron. But if I break it, I'm left with stone instead of iron ore. The reason for that is because my ore just has an assigned sprite, which was stone. It's not actually being changed based on the rock that's just been broken. So every rock that breaks is going to give me this stone. I need to be able to know which rock type has been broken. So if we remember back to when we configured all of the resources, so let's go down here in the scripts, we had rock data, which actually had an ore resource assigned to it. And then we had ore data, which was a little bit simpler. It had the name, texture, and the value, how much it's worth. Well, what we then did was link each of the ore resources into our rock. So if I go into my stone here, the stone ore is linked as the resource. The same for iron. So what I need to do is, when the rock is broken, pass this resource back into my ore scene. So that probably sounds a little bit complicated, but let's just have a go. And it's actually not that bad once we look at the code. So we head over to the ore scene, select the parent here, and add a new script. So that's fine, the naming is correct, but we want to move it into the scripts folder. So we'll create a script here, and right at the top we will create a new variable, which is going to be ore data. This is going to be the ore data class. This will ensure that we get the correct format for it. And then we can process that data. So the first thing we want to do is actually change this sprite based on whatever the ore sprite was. So let's get a reference to this node, drag it over here, holding control, and now I have a sprite2d variable. So we grab this, put it inside of the ready function, and say sprite2d.texture is equal to ore underscore data.texture. So whatever data we get from our ore, which comes from the rock, that's the texture that we're going to assign onto our sprite. And that's almost all for the ore function or the ore script. In fact, I don't think we even need a process function, so we can delete that one. But now we can go back into the rock script, and when it's broken and it drops the ore, so we pass on the ore position, but we also want to say ore.oreData is equal to data.oreResource. So I can explain that one more time. The data variable inside of the rock, if we go to the top, is the rock data, which is this resource. And that resource has an ore resource inside of it. So we pass that ore resource down to our ore, and that becomes its own data. And what that contains is the name, the sprite, and the value. So basically the rock itself knows what it is, whereas the ore doesn't. So when the rock is destroyed, it takes its own information, passes it over to the ore, and the ore can then assign its own images correctly. So I think this should actually be enough. Let's go into the level and just reconfigure these. So right now we've got 4 rocks here, and they all use the iron resource, but I could change this to let's see, stone for one of them. And then let's run this. So now I have a stone in the middle and 3 iron rocks. So let's just start breaking them. That one, oh, that gave me an error. What did I do wrong here? Oh, I see. I guess this is the problem with typing at the same time as I'm explaining. I've stopped typing this word halfway through. So back in our OR script, I was supposed to change the texture of the sprite. And those of you following along probably noticed this and either fixed it or wondered what it is I'm doing here. This is supposed to be the texture. So now this should work. Let's go back to the level and F6. And let's try breaking it again. Okay, we've ended up with a little iron ore. Then we'll do the same for the stone. And this time it's a stone ore. So, or just a stone. So it does now work. It links the type of rock into the type of ore. So that's all working pretty well. I don't like the fact that the player is being drawn underneath everything. So let's just quickly fix that. I think that's easy enough. So now the player's in front of everything, but this is all pretty much working. We're now dropping the ores from the correct stones. So the next thing we want to do here is actually allow the player to pick up these rocks or these ores that are being dropped. And we've done this a few times already. It's just an overlap between the area 2D, which is our ore, and a body, which is our player, our character body 2D. So you might be able to do this yourself. I'll just give you a hint that this needs to be inside of our OR script. So you would configure this here and you would use a signal. So one of these signals is going to be the function that detects whether we've collided with the player, i.e. the player has picked up one of the ores. So if you already tried this yourself, or if you just want to see how we carry on, then let me show you how we configure it. So I've selected the ore scene here, it's the area 2D, and I go into body entered. Then I connect it onto my ore scene, which creates this new function for me at the bottom. So this function will return a body like before, and I need to detect what type of body that is, because only the player should be able to pick up these ores. With the rocks, we did that by adding a class name. So we'll do the same with the player if we haven't already done it previously, which we've not. So at the top here, we will give the player a class name, which is just going to be player. Now we can check for that inside of the OR script. As soon as we have this collision, we can say if body is player, then that means that the player is the one that's collided with the ore. And we could pretty much stop at this point and just delete the ore and say it's been picked up. However, we actually need the player to know that he's picked up this particular ore. So we need to pass this information back into our player. But before we do that, let's just check that it's working. So let's print out collected ore and save that, head into our level, press F6. Let me break one of these stones and there we go. It says collected ore. Of course, it's still there, so I can keep collecting it, but the detection is working. But eventually we will add an inventory. So that's why the player needs to know that it's collected this ore. So let's head back into the player script. And right at the bottom here, I guess it's a separate section. It's not, well, yeah, it's directly related to mining. So we can add another function here. And this is going to be called add_ore. Then inside here, we need an argument, which is data, and that is the ore data. So this will tell which, the name of the ore, the texture, which isn't that important at this point, and importantly, the value. That way the player will actually know what it is that he's picked up. So we'll add void at the end, it doesn't return anything. I suppose it doesn't return anything right now, but actually what this function is going to do is it's going to check if there's space in the inventory, and if there is, then it will return true, that there is space. That way, if the inventory is full, then the player won't be able to pick up the ores and they'll stay where they are. So we do actually need to return something here. For now, we'll just return true, because we'll assume there is no inventory and therefore the player is able to pick it up. That means that this void needs to be changed to a boolean. Then we head back into our OR script, and now instead of printing this out, we add a second if statement. So we'll say if body.add or, and what we pass in is the or data. Remember, this is now returning a boolean, a true or false. So if this is true, then we can delete this or. We can say q_free. So let's test this just to make sure it works. We break one of these rocks, and there we go. We picked it up successfully. Then the same again, and we pick this one up too. We are getting a warning here, which is saying that this new function we made, add or, isn't doing anything with this data variable. And I guess that's true. So we could just say print data, try this out again, and we should now get some information. So it's now telling us that we picked up a resource. It doesn't tell us anything else about it, but we could interrogate it further if we wanted to. But at least that's cleared our warning from before. So that has now given us most of the functionality actually for mining. But it's all a little bit dull, isn't it? There's no feedback, there's no sound effects. When we pick up the ores, or even when the ores appear, they just kind of spawn in place. We can definitely add a little bit of polish to this so that it feels a bit more game-like and a bit more fun. And that's what we're going to do in this next section. And the first thing that I'm going to add in this additional polish is how the ores are spawned. I don't want it to just appear where the rock was. I want it to kind of bounce out of there. So let's go back into the rock script. And when we drop the ore, we're going to create a little bit of animation for the ores. And for that, we're going to use a tween. So down here, after we've added it to the root. So we need to have created the ore and added it to the container. Then we're going to create a new tween. So this tween is going to be or.create tween. And then we want to create a vertical bounce effect. So let's do that first. Vertical bounce. So we take the tween that we've just created, and then we're going to apply it to a property of the ore. So then we say tween_property and start going through the arguments. So tween property, the first is the object we're applying it to. In our case, it's the ore. The second is the actual property itself, which is the position Y, so vertically. The third is where we want the ore to end up. So because the ore is bouncing up, we take its current position Y and let's subtract 20. So that's how far up it's going to bounce. And then how quickly or how long is that going to last? Well, let's say 0.3 seconds. So very quick. So I think this should be enough to test. Let me break one of these rocks and there we go. An ore appeared and it moved in a very linear fashion across the screen. It didn't actually bounce up. For that, we need to add some additional parameters. But this line is going to get very long, so we're going to add a backslash to break it over two lines. And then we'll say set_ease. So I'm actually continuing the function from above, but it's just too long, so I'm doing it over two lines. So set ease tween.ease. And you can see there's quite a few different options, but we say ease out, meaning that it starts fast and then it slows down. So it's kind of like gravity. The ore is going to move quickly up, but then as it gets to the top, it's going to slow down. So that's why it's easing out. And then we say set_trans for transition, tween.trans. And here you have, again, a number of different options. I'm going to go with quad. So it's a quadratic operation. Now let's test this out and see if it's any different. Let's break the one at the top. And now you can see it moved a little bit more gradually. So it did look like a bounce and then it slowed down at the top. So now we basically just need to do the same thing for it coming back down again. So let's copy this, paste it down below. And this time it's more or less the same. So we're applying it to position Y. And now the final position is just where it started. So it bounces up and then it comes back down to its starting Y coordinate. Everything else I think should be more or less the same. However, we don't apply these two at the same time, otherwise it's just not going to move. So we need to apply this one first and then this one after. And for that, we need to add a delay. So we'll set a delay of 0.3 seconds, which is exactly how long the first one runs for. So as soon as 0.3 seconds have passed, the first one's finished, and we can then start the second one. So let's try this out. I'll break this iron rock. That didn't quite work, did it? That wasn't very smooth. And that's because I didn't change the ease out. So in this case, it should be ease in. It's moving in the opposite direction, so we needed to do the basically opposite action. So let's test that. Head over here. It still isn't working. Okay, and I see the problem is this delay. So if I comment this out, run it again, it should work correctly this time. Yeah, so it bounces up, bounces back down. We will need this delay, so I'm not going to delete it. I'm just going to comment it out for now, and it will become clear why we need it shortly. So right now, we're bouncing directly up and coming straight back down. And that's okay, that's already not too bad. But I would like to also bounce sideways, so that it picks a random horizontal direction, and then it bounces out from the rock. So for that, we need another tween. So this is a vertical tween, we need a horizontal one. But we're not going to set a fixed distance like we did with the y coordinate. We're going to pick a random distance that is going to move in the x direction. So before we even create this tween, let's add a comment up here to say random horizontal offset. And we'll pick a couple of random variables. So we'll say random, why am I not spelling this right? Random underscore x is equal to a random float, which is randf underscore range. And the range is going to be between -15 and +15 pixels. So the bigger or the smaller you set these is how far away the ores could eventually bounce to. So now that I have this random distance, I'm going to set my target x variable to be ore.position.x plus random x. So just like I've picked an ore position y as my target, but with a fixed offset, I'm setting the same thing for ore position x, but with a random offset. Now we can use this to create our horizontal movement. So underneath the vertical bounce, add another comment for horizontal movement. And this will be another tween. So let's copy the ones from above and put it in here. So now we're going to apply it to the ore position x this time. And we'll replace this section, which is where it should end up, with target underscore x. And we're going to set this to 0.6. So it will last the same amount as the other two. They're 0.3 plus 0.3 seconds, and 0.6 is the total. And then lastly, we'll set ease out. So we'll test this out now, and let's see what happens. And okay, so it kind of did two different things. It first bounced up, and then it moved to the left. And that's because these are running one after another. So I actually need all the tweens to run at the same time. So at the top where I've created the tween, let's set a property. So tween.set underscore parallel is true. So now they're going to run simultaneously. Let's add a comment, run tweens simultaneously. If I run it again and break this rock, now it's kind of jittery and it just moves to the left. That's because we now need this set delay, because now they're all running at the same time. So let's test it again. It should be a lot better now. And we actually get a little bounce. Try that again, and another little bounce. But you notice the bounce it moves for a little while and then stops moving and falls. So I think that's to do with the fact that we copied over this section as well. If I get rid of that and just ease out, then I should get a more natural bounce effect. And there we go. I think that's looking much better. And it's randomized. Although both of them seem to have jumped to the left, we do get random left and right directions. So that's much better, I think, than what we had before, where the ore just appeared where the rock was. Another thing that I would like to add is that when the player hits the rock, there's like this little flash effect so that we can actually see a visual impact or a visual feedback that the rock has been hit. So let's add another constant at the top. This is inside the rock script, and the constant is going to be flash underscore color. And we'll just set this to be, well, it's going to be kind of like a white color. So let's define color, and let's see, can I just do this? Yeah, I think that should work. That just gives me pretty much fully white. And the way we're going to use this is by modifying the rock's actual texture. So if we head back over to our rock scene, select the sprite, and down here under visibility, there's a modulate property. So if I just adjust this, you can see it kind of adjusts the brightness. So I can use this to create this kind of flash effect. So if we go back into our script for the rock, this here is going to be the flash itself. So I guess that's not actually quite right, because this is basically as visible as it's going to get. So that's the current setting. What I need to do is add some intensity to it. So let's increase this to, let's say, 3. Yeah, so now it's going to be far more intense, and then we can modulate it back down to normal visibility. So let's go back down here and create a function after take damage, which is going to be called underscore flash. Then we add void, and what we'll do is we'll take our sprite 2D and we'll apply that, take that modulate property, and we'll set it to flash color. So I should actually be able to just test this directly. And oh, of course, I haven't called the flash function. So when the rock takes damage, we subtract some health, and then we run the flash function. I guess while I'm here, I can remove this health because we know all of that is working now anyway. So let's run this again. And yeah, so there you go. So we've increased the intensity, and that's what it now looks like. But of course, we want to then come back out of this because this needs to be a very, like a split second of a flash. So inside this function, that's fine. We've set it to that, but then we need to animate it back down. So we'll use another tween. We'll say tween is equal to create underscore tween. Then we take that tween and we apply it to a property. So tween property, we apply it on our sprite 2D. The property that we want to change is modulate. The target is going to be just back to normal. So basically white. So that is the current level. That's where it's at right now before I increase the intensity. And it needs to happen really quickly. So it will take 0.1 seconds. So now if we test this and I hit one of these rocks, you can see it just flashes for a second. Well, for 0.1 seconds, and then it goes back to normal. So that is pretty cool. I think that's much nicer than before. And the last thing I want to do, just to kind of finish off, so we've done the visual feedback, but I also want some audio feedback. So I'm going to add a sound effect for when the player hits a rock, and then a second sound effect for when the rock is actually fully destroyed. Both of these sound effects I've got online. They're free, open source, and I will include them as resources for this project. But we need to get them into our file system before we can use them. So we'll head back up here onto assets. So minimize all the rest of this stuff. Next to images inside the assets folder, let's create another one, which is going to be called audio. So now we have images and audio. And in there, I'm going to move pickaxe hit and rock breaking, these two sound effects. So now I've got these two sounds in here. First, let's apply the pickaxe hit sound effect. That's actually going to be on the player. So we head back into the player scene and add a new child node. This is going to be an audio stream player 2D. So that's what plays music. Let's change the name of it to pickaxe hit sound. And then we need to assign a sound effect to it. So pickaxe hit from here, we just drag it over to the sound effect. Then inside of our player script is where we're going to actually play that sound effect. So let's head to the top, drag it over here holding Control so that we've got the variable for it, and then we can play the sound effect. However, we only want to play it when we've actually made contact with a rock. So not just whenever we swing the pickaxe, which is defined by, this input here and this use pickaxe function, because we might not be in front of a stone. We only want to play that sound effect if we've hit a stone. So that is done at the end of our animation. So it's here. Once the animation's finished and we check if we've hit any rocks and we found a rock, then we're going to play that sound effect. So we get the variable and we say .play. And I think that should be fine. So if I go into the level and head over here, so I don't know if my recorder picks that up, but I can definitely hear the sound effect from it. And if anything, it's a little bit too loud. So I'm going to adjust the volume of it slightly. I'll head back into the player and the sound node. And over here, I can change the volume. So I'm going to lower it quite a lot by 10 because you're going to be mining all the time. So I just want a really barely noticeable sound just for some feedback, but I don't want it to become annoying. So that's our first sound effect, but the other one is when the rock is actually destroyed. So we head onto the rock scene and do the exact same thing. We'll add a child node, which is audio stream player 2D. We'll rename it to rock breaking sound. And then we can drag over this rock breaking over here. And then inside of the rock script, we do, well, basically the same thing as what we just did for the player. So we drag over this sound effect so that we've got the variable available to us. And then we'll grab that variable, copy it down to in our destroy function. So before we even queue free, which is where we delete the object, we're going to play that sound effect. So let me test this out again, head back to the level, F6, and I'm going to break one of these now. So I didn't actually get a sound effect there. And the reason for that is because as soon as we start playing the sound, we actually delete the entire rock scene. And the sound effect is attached to that rock scene, so it gets deleted with it. That means we actually need to apply a little trick here. We don't destroy the rock until the sound effect is finished. What we'll do instead is hide it. So we'll say hide rock. The way we do that is just by taking the visible property and setting it to false. So the rock is now invisible. However, it still has a collision shape. It's still physically there. So we need to turn off the collision shape so that the player isn't then faced with an invisible wall. To get the collision shape, we head back into the rock scene because I don't think we've referenced it yet. No. So we grab it from here, drag it over, and now we have our collision shape 2D. So back inside of, destroy function, we make it invisible, we take our collision shape 2D, and we want to disable this collision shape. However, we can't just directly disable it. If we do, there's going to be errors in Godot. The reason for that is that a collision shape is part of the physics engine. So the physics engine is constantly running, always checking for collisions. If one of these collision shapes suddenly disappears while it's checking, it's going to cause problems in that engine. So instead we use something called set_deferred. What we want to defer is disabled. That's the property. And then we add true. So the disabled property is going to be set to true, but only when it's safe to do so. That's what setDeferred does. Once the physics engine has run through a cycle and it's ready to make any physics changes, that's when it's going to set this to be disabled. After that, we can play the sound effect. But we still can't quite delete the object right away, because then none of this will make any difference. We're going to hide it, play the sound effect, and immediately delete it anyway. So we actually need to wait until the sound effect has finished playing. And our sound effect has that property. So what we can do is wait for it to finish by saying await. We'll await rock breaking sound dot finished. And that basically means that this function is going to stop at this point, and it's not going to run the next line of code until the sound effect is finished playing. So let's just test that out and make sure it's working. Let's break one of these. I can still, you see, there's still an invisible wall there. I can't seem to get through it. And now it's disappeared. The reason it took so long, I think, is because the sound effect actually has quite a long tail. So I can either modify the sound effect itself by just chopping off the end of it. Like if I go into the rock here, I wonder if I can see it. Yeah, it's quite long. You see, it lasts 4.5 seconds. So another thing I can do is just to increase the pitch. If I double this, the sound effect seems to run twice as fast. However, that doesn't actually explain the problem. I'm not sure why this didn't work, because the collision shape should set to disabled pretty much immediately. And as usual, it's a result of typing while explaining. So I missed a D at the end here, and I didn't get an error. So disabled is the property that I need to change. So this time, I think it should work that as soon as I break one of the rocks, I can now walk through it. So the rock is still visually or physically there, but the collision is disabled and the visibility is turned off. So as soon as that's happened, basically it can do all the tidy up it needs to do. Play the sound effect and continue processing, but the physics for it are already turned off. But I think that sound effect is also a little bit loud to be heard repeatedly. So let's change the volume down -5 on that as well. But now we're pretty much done with the rocks and the mining mechanics. So we'll finally be able to move on to the next stage, which is going to be generating the levels and automatically creating all of these different rocks for us. So now we can move on to actually creating our level. We'll need some more images for that, and I'm going to use that same asset pack that we used for all the different ores. So this asset pack has a really nice tile set for this kind of underground mines. Here I've got that asset pack opened up, and inside tile sets is where we can find all the different images. The ones I'm going to need are ground dark, ground deco 5, and wall cave. There are a few other ones that you could also use if you wanted to, so you could add a little bit more to the game, but I'm just going to keep it simple and use these 3 for now. We need to add those images into our projects though. So we head over into our file system under assets and images, and then we're going to create another folder here, which we will call tileset. I can then grab those images from the asset pack, drag them over, and that's going to load them into my project. So now in here, I've got those 3 tile sets. To actually use these, we're going to create another scene. We'll start off with just a parent node of node2d, which we'll rename to map. So this is kind of going to be the main container for each of our maps. And before we go too much further, I'm just going to save it at this point. So normally we save everything inside of scenes, and I will do the same, but I will actually make a subfolder in here. And this subfolder is going to be called levels. This way I can organize all of my maps together in one place. Although this one is called by default map, because that's the name of my node, I am going to rename this to base_map. The idea is that this is going to be sort of like a template. So we'll create this base map and then we'll reuse it for all of the different levels that we're going to create for this game. So let's switch over to the 2D view and we can start actually building out our first level. All of these images need to be used with a tile map. So we'll head over and add another child node and search for tile map. And you'll notice that it gives a tile map and then a tile map layer. In previous versions of Godot, tile map is what you would have used, but that's been deprecated, and that's indicated by this little red cross here. Instead, it's been replaced by the tile map layer. So that's the node that I'm going to add. And then I can rename this to be the ground. So now let's configure this ground. If we head over on the right hand side, we can create a new tile set. And that brings up these 2 options down here, tile map and tile set. Tile map is what we'll come onto later on, but first we need to actually load in or create our tile sources. So down here on this plus icon, we'll select Atlas, and we can then navigate into our different tile maps. So I go into Assets, Images, Tile Sets, and it doesn't really matter which one we start with, so let's just choose Ground Dark. It's going to pop up with this menu here. So normally I would just select yes, but I'll show you what happens if I select no and what the difference is. So if I select no and I zoom in on this tile map here, or this tile set rather, you will see that the image from before, it's been split up into individual tiles. And that's essentially how these tile sets work. The idea is that they're reusable. So just from this one image that contains, 15 tiles, I can create an entire level by just reusing them at different points. But these are currently all grayed out, which means that I can't actually use any of them. They're all inactive. So what I can do is choose by clicking the ones that I plan to use within this game. So if I click them one by one, then these are the ones that will be available to me. And we can see that if we head over to the tile map tab here, I can now select any of these, but I can't select these ones, they're grayed out. But in this instance, with this particular tile set, I actually need all of them. So I'm going to click them all to select them. When that pop-up menu came up earlier, I could have clicked yes or no, and I selected no. If I'd clicked yes, it would have just selected all of these for me automatically. So basically, if I plan to use all of the tiles anyway, then just select yes, and it will do all of this for me. So now we can start drawing. We can come over to our level here, and we can use this purple outline as our rough guide for how big the level is going to be. Realistically, we don't have to stick to it, because we're going to have a camera that follows the player, so I could make the level bigger. But at least this gives me a frame of reference so that I can keep the levels to a similar size if I want to. In order to actually paint anything, we switch over into the, I select my tile map, and then I get the tile map tab here. So now I've got different drawing options. Let's say I've selected this one here, then I can use the pencil and just put it down anywhere on this grid. So that now gives me a little tile. And if I press F6 to run the scene, I see the first part of my level. And I can expand that. So let's say I select this one, click and drag, and select this one. Then I've created an extra little bit of my level. So this is essentially how we draw out our map. But there are tools that are going to make it a little bit easier. So for a start, I don't have to just use the pencil. I can use the line tool to, for example, draw a longer section in a straight line. I can use this to draw a rectangle in the middle, or I can use the bucket fill tool if I want to change the whole thing to something else. So these tools allow me to just draw a little bit quicker. There's also the eraser if I want to rub stuff out and just get rid of something that's there. But there's another shortcut for it, which is just to right click. So right click does the same thing, it will just delete or erase the tile that was there. But there is an even more powerful tool within Godot for quickly being able to draw large maps, and that is by using terrains. So if we head over here and open out the tile set again, down in the terrain sets, we can add a new element. So that will give me a new terrain, and I will create a terrain inside of it. So let's rename this to be our ground. We can then configure which of these tiles we want to be using in a terrain. So we head back over to the tile set, go into Paint in here, and then select the properties. So the property let's expand this. The property that we want is terrains, and the terrain set we want to use is terrain set 0. Inside that terrain set is the ground. So that's the terrain that we just created. We can then start painting specific parts of these tiles that would fall into that terrain. So here, for example, we select this tile, but only this corner of it is actually ground. The rest is just empty space. So we repeat that exercise and just making sure to select only the parts that are actually ground. So these are the parts that are going to connect to each other. So we'll continue selecting all of these here. And then I do the same for these 4 tiles. So here the walkable ground is just those corners. And the idea is just I'm highlighting the sections that can be connected to each other in Godot. So now that we've got these configured, we can use this terrain to automatically draw our map. So we head back over to tile map, and switch from tiles over to terrains. And we should see this terrain set, which is the one we just created for the ground. If you don't see anything here, which does happen and happened to me as well, it's you sometimes need to just refresh this by simply clicking on the map node and then clicking on the ground again. I don't know why it does that, maybe it's a little bug, but it then refreshes this and you should see the terrain. So now let's select our ground terrain, and we have all of these different tiles that are already mapped in. But this time, let's say I just choose the rectangle tool and I draw a little rectangle here. You can see what Godot has done. I didn't select any specific tiles. It's automatically worked out the different edges as well as the middle bit, and it's drawn basically a little island for me. So I didn't need to individually select these tiles one by one from the tiles here. The terrain worked it all out because it knows which tiles connect to which other tiles. And this is actually really powerful because I can even extend it. So let's say we draw something like this here. It will join it on. It will automatically work out that there's a corner here and allow us to very quickly create really cool designs. So play around with this, and likewise, if you want to delete any of them, just right click and it will do the same thing. However, it doesn't fill them back in. So you would have to then add the tiles back in by drawing something else in its place. So I'm going to delete all of this, start again, but that shows you how powerful this tool is. So now you can set up your own map, and in the meantime, I'm going to draw out how I want this level to be. So let's say I'll do something like this, create a little island here, a little path through, and then maybe another island next to it. Oh, I've messed it up. Delete that. I'll remake this island and this island, a little path through the middle, and then maybe another one here, extend up the way. It's really flexible, this tool, so you can pretty much just keep messing around, and if you make something that doesn't look quite right, well, you can just erase it and do it again. So that looks okay to me, that looks pretty good, but honestly yours does not have to be the same at all. So the restriction here is just whatever you want it to be. As long as you've filled out the, so let me come off here, as long as you've filled out the map at least, and in my case I've gone a little bit beyond it, but that's okay too. But that gives us our basic map. So if I press F6, I can run it and I'll see the level. Some of it is cut off, but that's fine. We'll add a camera to the player so you can run around and the camera will follow the player. But you notice that the edges of our map, they have a different color. And then what's not been painted has Godot's default background color. So what I would actually like to do is paint an area around this that matches this color from the tile set. So then it's all going to look consistent. If we head back into our tile map here and then switch over to the tile set tab, it's not actually one of these. So let's see if I just select anything. All of these have an edge of ground as well as nothingness. We don't have just a complete square that's just this one color. For that, we need to go to one of the other tile sets, and it's actually this one. So let's create another atlas and load in wall cave. This time I don't actually need all of them, so I'm going to click no and just select the one in the middle. So now that I have this, I can head over to my tile map. It's not going to be a terrain, I'm just going to paint this as a normal tile, and I go into the bucket tool, select this middle one, and this is where it's really powerful. I can just click in between and it works out where to paint this area. In reality though, that's probably not going to be enough. Yeah, so we can see that the edges are still gray. So what I'm going to do is just select this rectangle tool and just draw a larger area. It doesn't really matter. As long as we can't see any of the default Godot background in the game, then that's the main thing. So I'll finish painting this, and now I should not be able to see any Godot background. So that looks a lot better now. It does look a little bit bare though, so there's a couple of more things that we need to add. One thing is the player spawn tile. So I would like to designate one of these tiles as the place where the player is going to be spawned. So let's go into our ground again, and we need to add another tile set here. So we'll create another atlas, And this time we use the last remaining image, this ground deco. I don't need all of the tiles, I actually just need the one in the middle again. So let's select that one, head over to the tile map, click that, and just with the pencil, I can place it anywhere I want. So I'm just going to put it kind of in the middle. So let's put it here. By its own, that isn't going to do anything, but visually it tells me that this means something different to the rest of the map. So I'm going to place my player on this tile. And the way I'm going to do that is by creating a marker. So let's go back into our map and add another child node, which is going to be a marker 2D. So the purpose of a marker is exactly that. It just marks a position in 2D space. It doesn't really do anything beyond that, but then inside of our code, we can see the X and Y coordinates of this marker, and we can use it to position our character. So let's rename this to be player spawn. And then I'm just going to drag it over and put it right in the middle of this tile here. So now I visually know that's where the player is going to spawn, but I also have a marker which I'll be able to use in my code to get the coordinates for this tile. So that's one of the things I wanted to add, but the overall map is still quite bare. There's no features, there's nothing here. Well, if we go back into that asset pack and go outside of tile sets, there's another folder called props. And inside of props, there's quite a few different things that you could use. And I particularly like this railway image. So I'm going to create another tile set that uses these railways. So we head over into our map, create another child node, which will be another tile map layer. I will rename this to props. And then just to keep it consistent, I'll drag it up above the player spawn so that I've got my two tile sets, or my two tile map layers, and then the marker. And then the process here is going to be pretty much the same. So you could try this out for yourself if you want to challenge yourself and create the tile set using the ladders, and then see if you would even paint some of the ladders on here. So the way I'm going to do it is go into my props, create a new tile set over here, and then that brings up this tile set tab. We create a new atlas, and of course there's no images for it. So I have gotten ahead of myself. I need to grab the railway image and drag it over into my tile set folder. So now I've got it available here. We go back into this atlas, select the railway, and yeah, let's automatically create because I will use all of the tiles. Notice that it knows where there is no image. So these tiles in the middle are just blank space. So it doesn't select them. It just selects the ones that have actually got something in them. And I'm not going to bother with terrains here because it's quite simple designs. So we'll switch back over to the tile map and just pick any of these and start drawing some abandoned railways. Notice that the existing map has kind of gone gray, and that's because I'm working on the props tile map. So it's an easy visual to be able to tell the difference between the two, because if I select ground, it goes the other way around. So ground is now active and the railway is now kind of grayed out. So if you want to keep this kind of separation between your tile maps, this is an easy visual indication to avoid drawing on the wrong tile map. So let's just add a couple more here. I want to kind of break them up to show that this is abandoned, and so most of them have just, I don't know, have been destroyed over time, lack of maintenance, and they've broken down. So something like this. It doesn't have to be super detailed, but at least it adds a little bit more of a variety to our map. So that now gives us our base level. We can use this base map to create other maps and different variations of this for different levels for the player. And we'll get to that in the next section. Now that we have this base map, we can use this as a template. So instead of creating a new scene for our level 1 and level 2, we can head down into our scenes and levels folder, select the base map, right click, and then choose new inherited scene. And what this does is actually just create basically like a child or a copy of that base map. So let's go ahead and save this in the same folder as map_1. The useful feature here is that if I want to make, say, 5 different maps and they're all inherited from my base map, if I then decide I want to change something, like I want to add some more nodes, or I want to change tile sets, or maybe add some more props. If I do that inside of my base map, then it's automatically applied to all of the other ones, instead of me having to manually make the same change on multiple levels. And you will also notice the color of these nodes is different. So these are yellow, whereas normally all of the nodes are white. This indicates that they've been inherited from a parent scene. So here I could add another child. It doesn't really matter. Let's just choose another tile map layer. And this one comes up white. If I go back to my base map, it isn't there. But if I delete this, go back into my base map and create another child, and let's just pick a node 2D, save this, go back into map 1, and now it's appeared in here. So you can imagine if you have multiple different maps, it's so much easier to just change everything in one place rather than having to change it in multiple maps at the same time. So let's get rid of this node. And in fact, if I delete it from here, oh well, I can't. So it doesn't let me delete it from this node because it's inherited from the parent. So if I want to remove this, I have to go back into my base map, delete that node, save it, and it disappears from here as well. So that's actually just my map level 1. I'm not going to bother changing this one. We basically drew it already in the template. So I guess technically what I should do is erase everything from here and then draw everything here, so that each of the maps that I inherit are just a blank space for me to draw stuff onto. That would be the technically correct way to do this, but it doesn't really matter since we've already drawn it once. There's no point having to redraw it again, so we'll keep this as it is. But now let's organize all of this together inside of our actual level, where we've got the player and the rocks. Here inside of our level scene, we currently have our containers and the player. So let's instantiate our map. We want to start on level 1 with this game, so we're going to instantiate a child scene, and that child scene is going to be map 1. And that brings it through. So now I've got my level coming up. So far, for pretty much all the nodes that we've created, we've right-clicked and selected Add Child Node, and that gives us this big menu. But we can also drag and include existing scenes inside of other scenes. So that's what I just did there. I instantiate a child scene, which was our map 1. But you notice that everything else seems to have disappeared. And that's again just down to the drawing order. So we draw all of the different items and then we draw the map over it. And since it's so big, it basically just covers everything up. So we want the map to be the first thing on our level. So we drag it right to the top. Then we have the rocks, the ores, and the player. So now everything seems to be drawing correctly. Let's test this out and see how it looks. So everything looks pretty good. We can run around on the map. The player can go off the screen because we haven't got a camera yet. But more importantly, the player can just walk off the map. So right now this is just a 2D background image basically. It's not really being treated as a map in the sense that there is absolutely no collision. So the player doesn't know where the edges are and he's able to just walk straight through everything. So let's quickly fix these things. We'll start with the player. So we head over to the player scene, right click and add a new child node, which is going to be camera 2D. And then if I zoom out, I now have this purple outline, which is my new camera. So the camera is centered on the player and it's going to follow him around. And I think that's actually all we need to do. So let's head back over to the level and press F6 to see if that works. And it does. So wherever I go, the camera is following the player around. It kind of looks effectively like everything else is just scrolling past and the player is just always in the middle. But essentially that's what's happening. As we move around, camera follows him. And I do notice that I need to paint a little bit more of the tile map here just to cover up this area. And let's see if there's anything on the bottom. No, I think the bottom and the left hand side is okay, but the right hand side needs a bit more of this background color. And I can do that directly on map 1 actually. So let's head to the ground, select the wall, select this middle tile, and I'll just extend this out a little bit like so. So now save that back into my level, press F6, And I need to break these rocks. Now when I go over, there's a lot more of this space, so I'm not able to see the Godot background. Now we can deal with the more important issue of collision, so that the player can't walk off the edge of this map. And we're going to do that inside of our tile set. So we'll head back into the base map again, go into our ground tile set here, or the tile map layer first. And if we go and expand this tile set here, select physics layers, and we add an element. So this now creates our collision physics layer. We can now start assigning physics and collision onto individual tiles in this tile set. So let's head back over to the tile set, and let's see. Basically everything that has this dark area next to it needs to have a collision shape. So what we do is head over into select, and let's start with the top left here. So we by default have a whole bunch of options. The one we want is physics. So when you open up physics, we'll get physics layer 0. If you don't see this menu, it's possibly because you haven't created this physics layer over here. But once we have that, we can draw this rectangular shape. So let me get rid of this, and we can just start. I guess I can just clear it. So what we basically want to do is draw a tiny little square around this walkable ground. So essentially we need to mark out the areas which are going to be collision boxes. Just in the same way as we've created collision shapes previously, and we've just drawn where we want the collision to be, we need to do the same thing with our tile set. So back in here, let's scroll down, I've got this one selected. That basically means that all of this dark area here needs to be a collision shape. So I can draw that manually by just clicking on the polygon tool, and wherever I click, it's going to add a tiny little diamond. So I can try to manually click like this and define the shape, but you can see that it's not very accurate. It's quite tricky to get it in the exact correct pixels. Let me just zoom in a little bit. So what we do instead, I press C to clear this. I can select snapping. So here I can turn on, let's say, half pixel snap. And now it is a lot easier to place, well, still not that great actually. Maybe we go with, let's finish this, press C to clear it. Maybe we go with grid snap. That might be a little bit better. Yeah, so it basically just splits it up into a small grid of 4x4. I could adjust the size of the grid, but I think that's more than enough. So now we can go and select things directly on the grid. Oops, let's zoom in. I don't know why I did that, but if I zoom back in, close this, and now I have a collision shape that covers the entirety of that space. I know it's not 100% perfect. If we zoom in, we do have a little bit of space around here, but that's okay. You don't actually want it to have a collision immediately at the edge. We can definitely adjust this once we start playing the game and test it out, but for a starting point, this is probably good enough. And now we just repeat the process. So then I select the next tile, and I'm going to draw the same thing. So we just draw a rectangle here. The next tile does basically the same kind of collision as the first one. So although there's no gray space here, this is technically the edge of that tile. So I need to make sure the player can't walk on it. So then the same thing happens here. And I think I will just fast forward through, or I'll skip through the rest of them, but you get the idea now. So you just need to follow this around and make sure that everything that's outside of the walkable area has a collision shape on it. And when you've finished, it should look something like this. I did make a small change, which is that on the ones that have got the complete cliff on the edge of it, I've actually extended it a little bit. So rather than being like this, I've pushed it up a little bit so that the player can't get right to the edge, but there's a little bit of an invisible wall here. So I did that with these 3 tiles, and then the corners of these 2 and the inside corners of these 2. So these collision boxes are a little bit bigger. But now that we've configured these, that should be pretty much everything that we need. So let me save this, head over to the level and let's just test this out. See if it does work. And it works perfectly. So the player is now able to walk just to the edges and no further. As soon as we get to the edge, it gets stuck and, well, can't walk off the edge anymore. So I think that is looking pretty good. And yeah, so on the corners, we didn't extend the collision shape all the way in, but yeah, I think that looks pretty good. I don't think it looks like the player is falling off the edge because the collision shape does extend a little bit beyond his body, so it keeps him on top of just the walkable platform. So that is now our level coming together really well. We've got the collision set up and the map is already drawn out. So the next thing we really need to do is actually have these rocks automatically generated, because I don't want to manually create the rocks here. It's a procedural game. So we'll focus on that in the next section. Now we can start adding some actual rocks onto the level automatically. The way we're going to do that is by creating a script on our level node that's going to automatically generate a bunch of rocks. So go ahead, select the level node, create a new script, and then we save it inside of our scripts folder. So this will just give us a kind of blank template of a standard script. We don't need the process function, but we'll hang on to the ready function. So to create these rocks, let's add a new function called generate_rocks. It doesn't take any arguments and doesn't return anything, so we just add void at the end. And then we have to break down our logic into multiple steps. So the first thing to do is to actually remove any rocks that might be inside of this container. So that might be because I've manually put some rocks down here, so we obviously want to get rid of these before we make new ones. But also it's good practice anyway, because we could be changing from one level to the next and there might be some rocks left over, in which case we want to clear them all and create new ones. So let's start by clearing all the existing ones. That means that we need access to the rock container. So we drag that over into our script holding control, and that gives us the rock container variable. Now inside of our function, we'll add a comment which will say clear existing rocks. And what we're going to do is get the children of this rock container. So we'll copy this variable and say get_children. In this case, it's just going to return these 4 rocks, and we want to iterate over them. So we're actually going to add a for loop at the start. We'll say for child in rock container get children. That way we can go through each of these rocks one by one. And what we'll do with them is just delete them. So q_free. And we can actually just test this right away. So if we take this generate rocks function and put it inside ready, if I press F6 to run this, I now don't have any rocks. So even though I placed them here manually in the editor, they've now been deleted. So the next step is to create new rocks. So let's create a variable called num_rocks, and let's just make this, we'll set it to an integer and let's make 20 rocks. The next thing would be to actually place them onto our map, but more specifically, we need to know where we can put them. So if we go back onto our 2D view, we have to know where the ground is. So we can't just put rocks on empty space or on top of where the player is or on top of these railroad tracks. The only place that we can put the rocks is actually on this walkable surface. That means that we need a way of telling from our tile map where it's safe to put rocks. So if we go back into our map, actually no, that gives us map 1. So let's go into our base map instead. And we select the ground. We've got our different tile sets, but the one that we're really interested in is this one here, because this represents most of our ground. Now on the right hand side, inside of our tile set options, we've configured so far a physics layer and a terrain set. There are a few other things we can configure, one of them being custom data layers. So let's add an element in here, and we're going to name this element, let me just resize this a little bit, can_spawn_rocks. So this will allow us to define which of these tiles are allowed to spawn rocks. So now we've got this custom data layer, we can use it to assign that onto our tile set. So if we head back into the tile set, select this one, go into paint, and previously we were working on physics and that's where we're adding the collision. So let's change that over to our custom data and can spawn rocks. And now you notice there's a bunch of nulls, and that is not quite right, because what this should show us is our custom data layer. Okay, I missed one step here. So this variable, this layer, has to have a type, and the type is going to be a Boolean, because it's either true or false. So you can either spawn rocks or you can't. So now you can see this is turned into little checkboxes. And the only one that can spawn rocks is this one in the middle, because that's the only one that's fully a solid piece of ground. So I'm just going to select can spawn rocks and tick this one. So now I've marked my tile set, and wherever I use this tile, this middle one, which is basically anywhere that the player can walk, that is where I'll be able to put rocks. So let's save that and head back into our level script. And now we can create an array of all of the different available tiles on our map. So before we even create any of these rocks, after we've cleared the existing ones, let's define some variables. So we'll add a comment to say get tile map layers from current map. So we need to be able to fetch, if we go back in here, the ground layer and the props layer from our map. But the map is a node on its own here. We can't directly access those children. So what we'll do is create a reference to this map. If we drag it over with control at the top, we create a new variable. And we're going to call that current underscore map. So as soon as this level loads, that map is assigned to this variable current map. Now we can grab this and use get underscore node and pass in the name of the node we want. So the first one we're going to get is ground, and then we'll come back and get props. So for ground, we'll just put in ground in here and assign it into a variable. So ground underscore layer is going to be equal to that node that we're fetching. We should add some typing in here so that the variable knows what to expect. And what it should expect is a tile map layer. So now we just copy this down and do the same thing instead for the props layer. So it's going to be a tile map layer and the name of it is props. So now that we've got both of these layers, we need to know on the ground, so let's head back over to the map, 2D view, on this ground layer, which of these individual tiles are actually used. Because in reality, the tile map is, well, it extends beyond my existing level. But if I hover anywhere, you can see down here in the bottom left, it shows the coordinates. So up here, it's 0, 0, and as it extends onto my map, the number is changing. So I need to know the space and the coordinates that each of my individual tiles actually occupies. So back inside of my script, we're going to get that information. We'll say ground underscore cells is going to be the ground layer dot get used cells. So that immediately tells me where I've actually painted any of these tiles. And then I'll create another variable, which is going to be available cells. And this is just going to be an empty array. So right now we know all of the cells that exist, but we know that some of them might have railway track on them and some of them might be edges. So we'll start with the information from all of the cells, and then we'll filter the ones that are only available, and we'll put them into our available cells. So to do that, we need to go through each of these ground cells one by one. So let's add a for loop that says for cell in ground cells. And then we want to get information about that cell. So let's add a comment to say get the tile data for this specific coordinate. We'll create a variable called tile data, and that's going to be taken from our ground layer dot get cell tile data at that particular cell. So our ground layer is the entire tile map for our ground, and then we're going to get the data for the specific cell that we're now iterating through. So now what we can do is check that tile's data, custom data, and see if it has can spawn rocks. And if it does, then that's great, we add it to available cells. However, if we go back into the 2D view, our props layer sits on top of the ground layer. So this cell here, for example, technically can spawn a rock because the ground layer underneath is just a normal tile like this one. So I actually need to exclude any of those tiles that have a prop sitting on top of them. So we'll check that first in here. So after we've got our tile data, before we check if we can actually spawn anything on it, let's add a comment to say, check if there are any props in the way. And the way we do that is by checking for something called the cell source ID. So we'll add a comment explaining this, which is that get cell source ID returns -1 if the cell is empty. So we can basically just check if it's not -1. So if the props layer dot get cell source ID at the location of that cell that we're checking is not equal to -1, that means that there is something there. So if it is, then we need to just carry on into the next iteration of the loop. So we'll just say continue, and we're not going to run anything else. We're going to restart the loop on the next cell. So we're basically dismissing that current cell. But if this condition is not met, then that means that we have a cell, there's nothing on top of it. So then let's just check, can we actually put a rock on it? So let's add a comment to say check if this tile has the can spawn rocks property set to true. And I guess that comment pretty much explains exactly what we're going to do. So we've got the tile data. So we'll say if it has tile data and that tile data dot get custom data, which is the can spawn rocks that we've just added, can spawn rocks is true, then we've met all of our conditions. So in that case, this is an available cell. We can definitely put something on this rock, on this cell, because it is a spawnable one, and there are no props on top of it. So we take our available cells array and we append this cell onto it. So now the good thing here is by the time this for loop finishes, we will have an array that contains all of the possible places that we can put one of our rocks. The problem here though is that everything goes linearly. So it's working through the cells one by one in a pattern. So I actually want to randomize where my rocks are going to be placed. Otherwise, it's just going to fill the first 20 available cells. So to randomize it, I will simply shuffle this array. So once we've finished everything and the for loop is completed, we will take this available cells array and shuffle it. Now we've really randomized it, and we have, well, I guess we have all of the available cells. So we're not actually restricted to this number of 20. This just tells us as many as we have. So what would be better, rather than defining a fixed number of rocks, is to actually use the available space. That way, bigger maps can have bigger number of rocks and smaller maps will have fewer rocks. So it actually becomes proportionate to the amount of available cells. So in that case, we need to use a percentage. So let's go back to the top, and right at the top here, we'll create a constant, which will be fill underscore percentage. We'll set this to a float, and it will be equal to 0.4. So 40% of the map should be used for rocks. And again, that's a number that you can play around with to see what's right. You want to give the player enough rocks to break, but I guess you don't want it to be overwhelming so that you can actually proceed to the next level. So now instead of fixing a number of 20, we still want it to be an integer, but let's get rid of this. Instead, we're going to use a formula. So we're going to infer the type, and it's going to be available cells dot size. So that tells us the size of this array, meaning it tells us how many individual cells are available. And we multiply that by our fill percentage. So this will tell us how many, so let's say there's 100 available cells and we've got a percentage of 0.4 or 40%. That means we're going to end up with 40 available rocks, or 40 rocks to place. However, we could end up with a float here, and we can't place 1.5 rocks. We always have to have an integer. So let's wrap this inside of an int. So whatever number we get is going to get converted into an integer and then stored inside number of rocks. And I see I've made a typo. Available cells, there we go. So before we go too much further, because there is quite a lot of code here, let's just print out some of these things. So let's print num rocks, and I guess we can print available cells as well. So let's go back to our level and run this. Okay, so what do we end up with here? This is a massive list of all of the different locations where we could possibly put one of these rocks. And then at the very bottom, we have a number of 57. So that's how many rocks we could put, which is the 40% of our available space. So now that we've figured out where we can put the rocks, let's actually create them. That means that we need to get the rock scene, which is inside of our scenes folder, this one here. We need to preload it, and then we can create as many instances as we want inside of our level script. So right at the top here, we need to make sure that we're preloading this scene. So let's say const rock underscore scene is equal to preload. And let's see if we can find it here. Can I just type rock? Yeah, rock dot scene. So make sure you don't select the script. It's the scene that we need. Now that we have this scene, we can go back into our generate rocks function. And instead of these print statements, we know the number of rocks and we know the available cells. So let's just iterate for I in range num rocks. So basically go through every one of those number of rocks. And then we'll say our cell is equal to available cells at index I. And then we create a rock. So a rock is going to be the rock scene dot instantiate. That creates it, but it doesn't actually add it anywhere yet. So before we add it, we need to know where we can put it. So let's add a comment to say get local position from tilemap. Because right now we're working with cells, and cells have these coordinates like 5, 5, 17, 5. That's its location on the grid, but we need to know its pixel location. So we can calculate that using a built-in Godot function. We'll say the local position is equal to our ground layer, which is our tile map layer for the ground, dot map to local. And what this does is it takes the map coordinate, which can be something like this, and it turns into an actual pixel coordinate. So what we put in here is the cell. Then we update the rocks position. So our rocks global position is equal to the local position we got from the tile map. And finally, once we've done all of that, we can add this rock into a rock container. So let's grab the rock container, add a child, and the child is this new rock that we just created. So let's see if this works. Go back to our level, press F6, and it did. We have a whole bunch of rocks. So I think it worked pretty much perfectly. Okay, excellent. So we can run around. The collision is working pretty well. Let's see, can I mine them? Yeah. So everything is working well. They are all of the exact same type, which is something we'll have to fix later on. But the actual generation is working. They're randomized. There's, well, I can't work it out, but there's 60% at least, there should be, or 40% of the map is covered in them. And notice that there's not a single rock on top of any of these railway tracks. And the same for the player spawn point. So that way we can keep certain elements of this map free. So let's just clean up our level a little bit. We can move the player away and we can delete all these additional rocks since we now have a system for actually generating them. Instead, I'm going to move this rock off to the side as well. And what I do want to do is automatically place the player on top of this marker here. So we can do that, most of it at least, inside of our level script that we've just created. So we need to go to the top first, and well, I was going to say we need to get a reference of, if we go back to our level, of this player spawn node. But actually we don't do that at the top, because whenever we move through the game and we move to subsequent levels, we have to reload that variable. So we're going to do it in the same way as we've done with our ground and props layer. We recover it and we get it dynamically. So instead, let's create a separate function up here, just below ready. And this function is going to be called _position objects. And technically I should have done that with generate rocks as well. I should add an underscore here. So both of those are just functions used inside of this script. Then this doesn't return anything, so we add void at the end. And the first thing we're going to do here is get that player marker. So we'll say player underscore spawn is a marker 2D, and we fetch it from the current map. So just the same way as we've done here, we're going to say current map.get node player spawn. Now we can call this function from inside of our ready function, and we can do that before we generate the rocks. So we position the objects first, or maybe it's better the other way around. We'll set up the map and then we'll position the objects. That might make more sense. And now to actually position the player there, we could just grab the player node and update its position based on this. But as this game develops and we move from one level to another, there's going to be various properties on the player that we're going to change. So it's actually better to set up a function right away that resets and reconfigures the player. So let's head into our player script, and right out the top underneath our ready function, we'll create a new one called reset. And this reset function is going to take the position. So that's the starting position. We'll define a variable called pos, which will be a vector 2. This won't return anything. And for now, all it will do is it will take that pos and assign it to the player's position. So position becomes pos. And now if we go back to our level script again, we still need to get our player reference. So we drag him over, hold control, and now we have the player variable. But what we can do is, instead of directly changing his position through this script, we just call the reset function. And inside of that function, we pass the player spawn. Or rather, the player spawn is the node, so we need the position of that node. So let's see if that works. Save everything, press F6, and there we go. The player has appeared on this tile here. So even though on the actual editor in the 2D view, I've moved the player off the screen, as soon as the game runs, we get that player position marker and put the player character there. So the next thing that I'll want to tackle is to actually improve this generation of rocks, because right now they're all exactly the same. So what we'll do next is randomize it, create more rocks, more ores, and actually have this select different types of rocks depending on the player's depth. But we'll do that in the next section. But that brings us to the end of the basic setup. So now we've got the engine of the game complete. We've got pretty much all of the basic functionality, but to take this to the next level and really turn this into a playable game, there are still a whole bunch of features that we can add. So if you want to continue with this tutorial, then head over to my Udemy course, and I'll leave a link to that in the description as well as the pinned comment below. In that course, we're going to take this game much further. We'll add a lot more ores to collect, different types of rocks to break, and there will be ladders to allow us to progress through different depths in the game. The further we go, the more variety we're going to find, and the rarer ores are going to appear. There's also an oxygen system that's going to create a sense of challenge within the game, so that we can only be down in the mines for a certain amount of time. But of course, all of these things can be upgraded. So there's a shop system where we can take everything that we've collected from the mines, we can sell that and buy various upgrades to improve for the next run into the mines. So you can get all of that on Udemy, and I will see you in the next video.